Good morning. Good morning, sir.
Good
Our
morning. Good morning.
honorable speaker already joined. Shomdatta madam, start our sessions, today's sessions, and over to you, ma'am, to start with permission of our honorable speaker to start our sessions.
Acha, am I audible?
Yes, sir. Yes,
Okay,
sir.
okay. Thank you. Thank you.
Yes.
Hello,
Ma'am, you
good
can start.
morning, sir.
Yes.
Sir, am I audible?
Yeah,
Yes,
yeah.
ma'am.
Yes, ma'am.
Very good morning to all. I welcome you all in the fifth day and the final day of our FGP, which is 5 days online faculty development program on innovation in emerging fields. This is organized by IQAC cell and IIC cell of GKCEM in association with Department of Electrical Engineering, Computer Science and Engineering, and Wegrow. So today, this is the final session, and this session will be chaired by Mr. Raghunath Maji and Mr. Chaurus Brahman, sir. And today we really feel privileged to have our speaker today, Professor Dr. Shomdeep Ghosh. Sir is presently serving as the professor and head of the Department of Mechanical Engineering in GIS College of Engineering, Poland. He is also the director of IQAC. Professor Dr. Shomdeep Ghosh is an academician with more than 17 years of teaching and research experience in the field of mechanical engineering. He completed his postgraduate and doctoral from Jadavpur University in mechanical engineering with thermal specialization. He has authored more than 40 peer-reviewed journal and conference papers, book chapters, which are indexed in SCI, Scopus, Web of Science. Dr. Ghosh has also published 15 patents on several fields of emerging engineering innovation. He has delivered invited talks in several conferences, symposiums, workshops, and faculty development programs. His present research work is based on the tribological characterization of noble materials developed by electroless nickel coating methods. His other fields of interest includes the cooling of microchip heat sinks using nanofluids, renewability study of power generating units, non-conventional refrigeration process, high temperature analysis of coated gas turbine blades, etc. As the current NAC coordinator in this present institute, Dr. Ghosh has also mentored several institutions as a NAC expert. So, sir, Shomdeep Ghosh, sir, over
Yeah.
to you, sir. Looking forward.
Thank you very much. A very good morning to everyone. Acha, the way I have joined, I'm not visible actually. Do I need to join from other device also for camera, or is it okay?
Yes, sir.
Should I also join from other place? I mean, that will be a second joining actually.
Okay,
Okay.
okay, okay, sir.
Oh, probably it will create some noise.
Yes, sir. Now I make you call, sir.
Is it having resound?
Yes, sir.
Oh, that will be a problem. So I'm just keeping off it. Okay. Otherwise, it will be creating problem. Yeah.
Okay.
Okay, so very good morning again to everyone present over here. So I'd like to say firstly that already probably you have gone through 4 days of this FDP, and I am sure that you have gone through several different methods and the methodologies which has been discussed in various sessions. regarding the innovation, regarding the process of innovation, regarding the way the entrepreneurs are born, entrepreneurs are developed, they how they build their career, how they do the patenting, and how they make their own startups. I hope you have gone through many such sessions. I hope. So today I have come across some little different perspective of innovation, and I would just like to introduce you into this sector because there are a lot of places in which we work on and we think about doing innovations in several different fields of our interest. We look for the day-to-day problems, and at that point only we do innovation. We start thinking about the problems and we try to find out some solution. And when we find some solutions, then we test whether it has been made already, it has been done there. We search for it, then we find probably somebody has done it, somebody have done something about it. Some solution is there probably in the internet. Then probably we try to adopt it. If it is okay, then if it is not okay, or if it is not suiting your purpose, then we try to change it. And we try to develop, we try to, I mean, modify this, whatever is available already in the market, or what is available in the internet that we see, that we find. Sometimes we have products which solves our purpose or solves our problems, but sometimes we have to evolve with new thinking, then out of the box thinking. So that's how the session, this FDP is very important, which has been going through. I'm taking you to some different directions which one hardly thinks about the innovation part. Basically, if we talk in a general manner, that innovation is needed in almost every sector, in fact. So whatever things are solving our problems in day-to-day life, every place we need some innovations. We need some new things which should come up. So I'm just giving you a basic idea about the net zero, which is a very important thing for our future, and how the nuclear energy and its associated innovations in the mechanical engineering field, as well as the chemical engineering field or the other engineering fields, like in several instrumentation engineering fields, how they are coming across together and solving a lot of problems in these cases to enhance the scope of green future. So let us start. First of all, I would like to start with this some data, some effect of the climate change on global economy. You'll see that some reports from this Potsdam Institute of Climate Impacts Research, published in the journal Nature in few years back. Then the global economy is predicted to lose about 19% of its income as a result of climate change related events. I mean, it says that the income may get reduced due to the change in the climate, which is really a shocking news, that how the climate change is affecting our day-to-day life. Although it is visible when we see that some big storm is coming, some big natural incident is happening, and we find that, okay, due to the global warming, such things are happening. But it also costs the global economy. It costs the income of people. And India has a speculation that it may have a worst hit scenario when it may suffer around 22% of its income by 2050, which would amount to around $38 trillion. So this is a huge amount, and for a country like India, and it may give you a lot of reasons for working on different sectors, and start thinking in a new manner, such that the existing ones or the trend which is ongoing can be changed, can be reversed, can be gone to some different directions, such that we can avoid such big losses or such big things. Rather, we may convert the scenario of losses to a scenario of gains. I mean, we may change the way of doing it. So this is true, as it says that even if the efforts are made to significantly to reduce the carbon emissions, still these are the speculation at this point. Evidence shows that our planet has been getting hotter. Now the question is, how hot? It is another problem. Many people might have not thought about it. What is the exact average temperature of on Earth, basically? So as you see that the warmest 20 years on record have been in the last 22 years, according to the World Meteorological Organization. And it has seen that 2015 to 2020, it was the most hot zone for Earth. And another thing is important, as I was saying, that the global average temperature, if you just look the figure, you'll be, it will become funny to you that it is only 1.2 degrees centigrade. But this is basically higher than the pre-industrial area. So in the pre-industrial area, in the time of the pre-industrialization, this temperature was much lesser. So what we're talking about is 1.2 degrees centigrade, which is the average temperature. How many of you feel that it's a big temperature, or it's a okay temperature? What do you think? Anyone? What do you feel? This is a threatening temperature? What do you think? You can say something. Anyone? By this figure 1.2 degrees centigrade, does it look threatful to you that okay, it's a problem, huge? Probably not. Probably it looks like okay, it's a very small temperature. But when we go for, sorry, it's somehow it's stopped. Okay. Uh, Basically, when we check this data, a degree doesn't sound like a lot, but this incremental warning is already having a negative impact. So this 1.2 degree is enough, basically, to give you a problem, to give the earth a problem. Because we have seen a lot of things happening. Huge storms are coming, and we have seen a lot of destructions happened in last century. And that happened only because of this temperature. Now, if just see what's more, that if recent trend continue, this is set to worsen, with predictions of global temperature increasing by as much as 2.7 degrees centigrade by 2100. Acha, am I audible still?
Yes, sir, you
Okay,
are.
Yes,
okay.
yes.
Yeah. Okay. I was just
It's
checking because I'm not getting any word from anyone. That's why I was checking.
No, 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 no.
It is open session. I tell you, everyone can interact. Just it's like a discussion. So take it like a discussion. I'm not giving any knowledge transfer much. You have got a lot of knowledge from many experts. I'm just giving you introduction of a new place or new zone of interest, which may give you something. So when we look at this place, that even with this teeny rise in global temperature, we are feeling the effects of climate change with erratic weather patterns, including heat waves, floods, severe storms, loss of polar ice, and rising sea levels. We have seen the polar ice melting like anything, right? And we think about how warm the earth is. And now I gave you a figure that 1.2 degrees centigrade to this 2.7 degrees centigrade of the overall average temperature of earth. It's a huge difference, actually. And it can make the whole living on earth changed. We may get a water age someday, and these lands that you see in this picture may get down in under the sea. So if it may happen if the global warming intensifies. Now the case is, what is net zero then? Basically, we are in a need of uh, clean energy at this point. We need a sustainable society, right? Because we don't want to sink under the sea. We don't want to die. We need our generation to live. We need to prosper. We need technological advancements. And we need to basically, whatever advancements are happening, that's separated. But we want to live. That's the main point. The human race should continue. That is our main target. So what we need is like clean, we need reliable, and we need affordable energy for a sustainable society. And the way we can do it is it can be done by setting some goals, by setting some ways, paths. So that path, one of these path is a concept of net zero. So what is net zero? The net zero basically is a state in which the greenhouse gases going into the atmosphere are balanced by the removal out of that from the atmosphere or of the atmosphere. Means that there are two mechanisms should be happening side by side, and one in which probably the greenhouse gases are coming up, and in another some mechanisms in which the greenhouse gases are removed. So this is a stage which is kind of an equilibrium. This is a state at which the global warming, that is the incremental rate of temperature change, will stop, because you are not adding more heat. Because whatever absorption of heat is happening because of the greenhouse gases, then that is also removed in the process. So this was discussed in 2015 Paris Agreement, an agreement adopted by 196 countries, which aims to limit global warming to below 2 degrees Celsius. As I showed you the figure, that was a prediction of 2.7 degrees Celsius, but here we need to decrease that into 2 degrees Celsius. Below 2 degrees Celsius is your target, and preferably it is to 1.5 degrees Celsius. This 1.5 is a figure in which all countries agreed that this is our target. We have to reach this 1.5 and to keep it 1.5. So it's a very important figure, 1.5 degrees. And it requires to achieve a balance between, as I said, anthropogenic emissions by sources and removals by sinks of greenhouse gases in the second half of its century. So this century basically is ongoing, and within the second half of this century, we need to do all these things. To go net zero, it's to reduce the greenhouse gas emissions and or to ensure that any ongoing emissions are balanced by removals. I hope it is understood that what is net zero. Net zero is basically either you reduce the greenhouse gases to some extent, but if you cannot do the whole, so you need to also ensure that some of the emissions or whatever emissions that you have, then you have balanced by the removing them by some other methods. So what are the net in net zero? I think share screen has stopped. Is it so?
Yes, sir.
Is it now visible again?
Yes, sir.
Okay. So the net in net zero, what is this net means? It's important because it will be very difficult to reduce all emissions to zero. It's not exactly possible on the time scale needed, as well as deep and widespread cuts in emissions will likely need to scale up removals. So to really have this net zero, basically we cannot stop all the emissions. That is something that we need to understand, and accordingly we need to take measures for removing the gases. In order for net zero to be effective, it must be permanent. Permanence means that removed greenhouse gases should not again return into the atmosphere over time. For example, through the destruction of forest or improper carbon storage. There are a lot of other things of interest in this part, but that is much huge detail. I'm not going to that. But permanent or hard net zero refers to a balance between the greenhouse gas sinks and sources that is sustained over the matching time scales. So these are different type of net zero concepts, but I move again. Now it's stopped as the shared window is closed. What is it showing? I don't know. See, it's getting stopped. I don't know why. Share screen again. Is this now coming again?
Yes, sir. It's now visible.
It's stopping. I don't know why it
Yes.
is stopping sometimes. So what is our goal? The goal is to have various terms that we need, that carbon neutral, net zero, climate neutral. This points to different ways in which emission sources and sinks are accounted. And net zero as a goal, our target is by 2050, we reach these targets, whatever I say, that's this 1.5 degrees centigrade. So this there was a IPCC is Intergovernmental Panel on Climate Change, which concluded that net zero, this CO2 emissions, about the net zero point of view, by 2050, it has to be consistent with a maximum temperature of 1.5 degrees centigrade. So the purpose of this this whole discussion, I mean this whole point was to effectively have a climate action that is aligned to net zero. Now, this race is ongoing, and several places, those many actors will be able to achieve absolute zero or zero emissions. Means those who are acting, means those countries which are acting for this purpose may have an absolute zero or zero emissions, but this is the global race, like race to zero campaign. Like everybody is rushing to make a net zero at their point, at their point as an ambition actually. So others will need to scale up. Those who have already participated, the other countries are also need to scale up their removals, and either by directly by or by the supported by the other projects companies. I mean the countries which have already done a lot, they may also contribute to the other countries, which are small countries, which may also start the process. Now, here how India comes into the fact, as you can see that these are the targets that have been set by various countries. Like you can see, United States have set of 14%, the European Union has 7%, China is a huge. They have their commitment of around 28% reduction, and the countries with the net zero target of 11%, the 33% of the other countries, the similar net zero announcements, and India is having also the 7% total commitment in the whole process of this 89% in total. Still, some percentage is left. That is, the countries with no net zero target is 11%. If they also contribute, then the whole 100% net zero can be possible. So they are in process, but they will also try to contribute as supported by the countries which are doing something. So that's how India is there, and it is also having 7% stake on this huge mission, right? So how exactly we are doing it? So this slide may look a little bit complicated, but you just focus on the top rows. What are the things that we need to make this kind of mission impossible to become mission possible? It's like high quality energy efficient buildings. That is one of the primary things that we need. So a lot of innovative works you may see in various cultural fests in colleges. You can see that a lot of civil engineering students try to make the high quality, the efficient building models. And to be honest, that such kind of works should be identified, and such kind of works should be funded. And accordingly, the energy efficiency of such plannings, of such designs should be calculated, and accordingly, they should be given a scope to build their prototype, or should scale up the process, the whole setup, test them and find out whether really they are having a high quality energy efficient buildings or not. So that is a point where a lot of things to be done from the innovation point of view. There are other things like flexible zero carbon mobility, zero emission circular goods, abundant clean energy. We all understand that abundant clean energy is needed, and the whole process starts from the home. As you can see at this zone, where you can see that the healthier diet means the less food waste, then the regenerative agriculture and restored soil health, the protected biodiversity, the reforestation, and carbon sinks providing carbon offsets and agriculture. We all understand that reforestation has become really popular, and a lot of people are giving efforts on this part. And in this way, basically what we are trying to get is a sustainable natural ecosystem. In the energy point of view, we are trying to use zero emission products, as zero emission ways of doing it. Let's say abundant clean energy is this important point. As you can see, it is coming from zero carbon power generation by like solar, like photovoltaics, like the hydrogen ecosystem, that is battery cells, and the low emission fuels burning from sustainable biomass or synthetic sources of fuels, liquefaction of fuels, gasification of fuels is very much popular. Zero emission circular goods, as you can see, is like high quality products with longer lifetime and ability to repair. Like here again, the innovation comes into business, because whenever we are having the products, we are making products, that the efficient product building is a point of interest for innovation. So whatever product we make, we need to make it longer sustainable. So their lifetime has to be increased, and a lot of work can be done on this part to make the higher quality products with longer lifetime and ability to repair. So things should be repairable. We should not waste them, because we now know that recycling has become a big business now. But if we try to make such products which are repairable faster, which can have a lifelong process. Like in the battery technology, basically, huge things are coming up. A lot of technologies have been evolved by many scientists, even from Bengal. They are evolving with new technologies which can sustain a very, very long time. Some days back, I was looking at one ad. It was just showing some batteries which have been already used, exploited. Those batteries, the process is like you take those batteries and you uh, put them in a warm water, it's boiling water for 5 minutes, and then you dry them very much well, and then you still again try to use it. They become recharged. They are not rechargeable batteries that I'm talking about. I'm talking about the exploitable batteries which we use in our torches and all these places. They can be reused if you know the proper technology. So it means that if there are a lot of innovative point of views in such things like this zero emission circular goods, it's a point of interest where people can start working. Flexible zero carbon mobility, it's a big challenge, although the carbon free long haul transport, this is a very big challenge. Zero carbon logistics, I think you have seen a different types of fuel ratings when you try to book a flight. I hope how many of you have seen while you're booking a flight and you see that this much of percentage of carbon, and then the green journey, then this percentage of greenness. Have you, any of you have seen while booking a flight, the carbon percentage or the carbon footprint percentage is shown, and accordingly the prices are changing? Anybody have seen it? While you are moving to various places and you book the flights, then you'll see that there are some ratings coming up for every flight. How much green the flight is. Why these things are there? While when you are trying to book just a flight from Kolkata to Madras, then what is the need of showing you that this is carbon percentage, carbon footprint of this percentage, that percentage? Why? Because the whole system is about awareness, that if we are aware, then we can contribute. If we are aware, then we can rethink on a developed product. We can try to make this product in a new way and try to make it more efficient, more lifetime. I mean, we can enhance the lifetime of this product. So there are the different places when we can have the locations, and the policy of energy is very much important for sustainable development, where three important keys are there: that the total global environmental protection should be always kept in mind. With that, we need to think about any energy policy which is given for sustainable development must include the affordability and competitiveness in the market, and also the security and reliability of energy supply, because we are somehow so dependent on energy that we cannot just wait for a big pause for some shutdown period. So they have to be reliable also. I mean, it should not act like this: at the morning time we are getting some energy, at the evening we are not getting energy. Not possible. We have to have a reliability of some energy supply, and accordingly things changes. So as I was discussing the need of innovation in net zero, if we do the concept of energy transition, which is high on many policymaking agendas, it will be critical to ensure the right balance in the energy mix of future. So such policies should be made in that way. Nuclear energy, as confirmed by many intergovernmental panel on climate change, that it should play a very important role in the necessary energy transitions toward a very low carbon energy mix. Innovation is necessary to develop and bring new nuclear technologies that will be able to compete in the global energy markets of the future, being cheaper, more flexible, and faster to deploy. These are the three important factors which somehow thrust the nuclear power somehow in a far place of thinking. We generally do not think much about nuclear power because we have a concept that it is kind of very dangerous. It is kind of very, very costly, and these are some things that we generally keep things aside about this nuclear power. But I'll show you some videos and pictures that will make you understand how and why we should work on nuclear technologies. So this is from the past. We need to really make some changes to make them more flexible, faster to deploy. They should not take very long time to erect, and they should be also cheaper, because cheaper is a very important word in the context of India. We really need cheap energy, otherwise we cannot afford it. Then definitely people will not use it. Innovation also improves the process of bringing technologies to market in faster and more effective ways. So that's how the various stakeholders, the researchers, industry, regulators, and authorities, everybody can be combined together through the process of innovation, patenting, and a commercialization of various different new technologies which can be applicable. Now, I'm just giving you a quick view of what is the current global scenario of energy, and you can see that still coal is having the top mark of 35.12%. Natural gas is 23.37%. So they together is around more than 50%, 55%. And the renewables, hydroelectric, you keep it separate. It's a completely very old technology. Other than that, the other renewable energies is around 11%, and nuclear energy is around 10% or something like that. So this is a global energy production right now at this moment, and you can understand that again you have a lot of scope to work on this 10% of this whole part, with the continuing the work on the renewables, which is around 11% right now. And as you see that evolving, how the nuclear power generation is evolving from 1970s, this data is up to 2021, and in the left side, it is in terawatt hour. And you can see that West and Central Europe, how they have enhanced. You can see the North America, how they have enhanced the capacity. Then Asia also, and is at the bottom. You can see that it has also enhanced its capacity largely, and it is also again increasing day by day. And India has a large part in this Asian color. That is, you see the light blue color, which is showing the Asian part. And you see that Asia is actually having a lot of contribution from India in the nuclear power generation. Now, all of you probably know that how nuclear reactor works, so I will not go to this part, but this is just a basic scenario how the reactor is placed. In the left side is inside a containment structure, and the power is provided from the reactor vessel. The reactor vessel, it's consisting of fuel bundles, and the fuel bundles how is giving, if it is a fission reactor, then the fission is happening by neutron bombardment, and ultimately a huge amount of power is produced, and that has to be taken away. The biggest challenge is it has to be taken away by some coolant, and then it may convert the heat transfer to the further sections for the power generation. The same is applicable for various different technologies. Like one of the very important technologies which had come up by India. It was this, and especially the Canada. It is a kind of treaty between Canada and India that is called CANDU, the Canadian Deuterium Uranium Reactor, on which India also worked a lot to develop this reactor, which is primarily having a heavy water coolant, which is going through the reactor side, and primary the other is a light water, which is acting through the turbine and the other devices. So this structure is very much popular in Indian context and Indian power generation, this pressurized heavy water reactors. So this is how the reactor actually look if you try to see it up and close. And you see that a lot of instrumentations are over there, and basically we can see here the control rods, which are huge in numbers, and their main purpose is to control the rate of reactions. And that's how they become a significant role in controlling the power output of that whole process. I mean, the power output of this process, and a lot of things can be uh, get from that. Now, if we have a basic outlook on a comparative outlook, then and where in how why we will work on this nuclear technologies, and when we are basically advocated for the renewable energy mostly, then we need to see these points that as the world grapples with the urgent need for sustainable and clean energy solutions, the debate always is there. The nuclear energy or renewable energy sources like wind, solar, and hydropower continues to gain traction. Right? We always have a comparison, so that what should be done. And while renewable energy has been widely advocated for its eco-friendly attributes, nuclear energy also presents a compelling case as a more reliable and potent alternative. So as you can see, this picture is somehow gives you an idea that a lot of different things if you employ on a renewable energy part, and alone nuclear power plant can still be held in the same level. Both of them are clean in the sense. Why such things are happening because of the unmatched energy density. The nuclear energy stands out for its incredible energy density. A small amount of nuclear fuel can produce a massive amount of energy, far surpassing what is achievable with nuclear sources, I mean renewable sources. And this high energy yields means that nuclear power plants require significantly less fuel and space to generate the same amount of electricity compared to the renewable energy farms. So this is a point of interest when where you see how much of space is required, how much of developmental cost is required, because you know the word renewable energy is not a very small word. It's just a very, very big word actually. And if you go into deeper side, then you need to also analyze that when you are when you are making a plant, a renewable energy plant, then you are doing a lot of digging, you are taking a lot of place evacuated, you are making a lot of place maybe suffering some deforestations, or maybe a lot of other things that you are doing. Somehow or other, they are reducing the renewability index of it. Means what I'm trying to say that renewable energy production itself have an implication of carbon footprint in some other places, and the carbon footprints have uh, is already associated with the generation of renewable energy, which is very peculiar to understand. But although we are producing renewable energy, but there are implications for making a huge place covered with the solar panel, or huge place covered with the windmills and all other things. Everything is required definitely, but if you compare with in the perspective of economics, power economics, and in the compare with the perspective of the place or the amount of investment that you are making, and how much is wasted and how much is attributed, what kind of time is required, how compact the plant is, all these factors have some effects on the this power economics, and this all have some effects on the renewability index, the renewability. There is another term called emergy, which is another extension of you have probably heard of energy, then exergy, then there is energy, and there is another word called emergy, which actually calculates these effects, the renewability effects on of a production plant. When you make a power production plant, then there are different places in which you need to work in an innovative manner, such that those places, those works can be modified, can be changed to some extent, that you can save some energy in those places. Because energy production itself is energy taking at many points. So that's how much space you require to produce a certain amount of energy and how much place you are actually using, that is a big issue. Probably you have heard of second law efficiency, which says that the work that you are trying to do and how much effort you are giving to deliver that thing, that makes you different from others. When we do some job and we do a certain job, and 2-3 persons are doing the same job, and one person is taking a lot of people with him, and is giving nuisance and all other haphazardly that is being done. Ultimately it is getting to that result, of course, but many other things are changed or modified, or there are losses in various other fields to get to that job. Means a lot of energy has been taken to do the same job. To take the same job, if you are using different energies, then your second efficiency is different, because your ultimate output is same, but you are using different amount of energies. So basically your second efficiency is decreasing if you are using more problems, if you're creating more problems to do the same thing. So this is a perspective what I'm trying to tell you, that we need to think of both, I mean both the renewable energy plants as well as the nuclear energy plants together, such that one can be a stopgap for other. When we are not getting energy from one, the other may give the sufficient amount of energy to continue. There should be reliability overall. Consistent and reliable power supply, which is a point that I automatically came up. One of the most significant advantages of nuclear power is its ability to provide a consistent and reliable energy supply. Unlike solar and wind power, which are dependent on weather conditions and the time of the day, nuclear reactors can operate uninterrupted, providing a steady stream of electricity. This reliability is crucial for meeting the constant and often unpredictable demands of modern electricity grids. Modern electricity grids, uh, you know, they are it have unpredictable demands at many points of interest in many cities. The most important part which connects the net zero with this nuclear power is that lower carbon footprint. The nuclear power is one of the lowest carbon emitting sources of energy. Although the construction of nuclear plants and uranium mining have associated emissions, but the overall carbon footprint is much lower compared to the fossil fuels and comparable to the renewable resources. This is a very, very important point that many people doesn't know, that a nuclear power plant once made, then it is having a very less carbon footprint. The emission is almost negligible because the whatever you see the emission, that there is no point of emission. In fact, whatever cooling towers are used. Cooling towers basically, ejects the water vapor that you might be knowing. So there is hardly any emission because there no fuel burning is happening in that process. So with the urgent need to reduce the greenhouse gas emissions, nuclear energy is a viable options for a low carbon future, which is a important stake. The most important part here is the technological advancements. After the carbon footprint, the second most important part is the technological advancement, which have made the whole process very, very compact, very, very safe. The field of nuclear energy is rapidly evolving with advancement in technology, making it safer and more efficient. The efficiency has been, mind-blowing. And innovations like small modular reactors, these SMRs and generation 4 reactors promise enhanced safety features, reduced waste, and even the ability to utilize the existing nuclear waste as fuel. This is the most important part. I'll also come to this later also, but this is a point where again it will be repeated that the small modular reactors or the generation 4 reactors which are coming up are really some places to work on, think about on, and give your brain uh, do some research on them and then evolve with them. These developments could mitigate many of the traditional concerns associated with nuclear power. Long-term sustainability, while renewable energy sources are often touted for the sustainability, the intermittent nature of these sources can be a limited factor. Nuclear energy, on the other hand, can produce a steady supply of power for decades. With ample uranium reserves and the potential of breeder reactors and thorium, which is abundant in nature of India throughout the coasts, especially the east coast, we have a lot of thorium. The nuclear energy offers a long-term solution for global energy needs. This is a future. NI 2050, it's in 2015, basically, the NEA, the Nuclear Energy Agency, launched a Nuclear Innovation 2050 framework, an initiative to accelerate the R&D and market deployment of innovative nuclear fission technologies. The NI 2050 is a broad initiative for nuclear innovation. As I said, they're potentially covering a wide scope of technology areas and addressing reactor systems design, operation, fuel and fuel cycle technologies, waste management and decommissioning, and applications beyond the electricity generation, in particular to the tackle of potential of the heat market and the corresponding increased flexibility in operation. These are some advanced things, but basically this is an initiative for the nuclear innovations. The World Bank or there are a lot of points where you have got the place of interest. You have the scope of doing work in the nuclear innovation sector. This is just a close look of the whole thing, how things are working. This is just the instrumentation level I'm just showing you. One second, please. So three innovations that transforming the nuclear industry is new classes of advanced reactors, the advanced manufacturing, and advanced fuels. These are the three important points where the things are evolving. And the new technologies, how it's coming up, they are making the problems associated with nuclear technology at many points, which could use a threat as a threat someday earlier, that has been resolved by many places. So the new classes of advanced reactors, the advanced manufacturing, and advanced fuels. This is a picture of the nanocenter training in the method of pulsed laser deposition at National Research Nuclear University in Russia, Moscow. Innovation and technology development at all stages of nuclear fuel cycle, in fact, from the latest uranium enrichment technologies to the design and implementation of small modular reactors. This SMR that I was referring in previous slides also, the small modular reactors are very important, and they are basically giving you coming up with the latest uranium enrichment technologies. Uranium enrichment, I just try to tell you what is it. It is basically enriching the uranium particles in the fuel such that fission is sustained. The fission, if you start with the neutron bombardment, it needs sustaining, right? So that it goes on continuous basis. That's why uranium enrichment is needed. And that is a point where a lot of reactors may fail at some point. So that failure is, avoided by the continuous research in nanocenters, disruptive technologies such as additive manufacturing and artificial intelligence, that is also helping this point to enhance the plant efficiency on this part. The new classes of advanced reactors, as I was saying, that the SMRs, modular reactors, which are pilot reactors. So this is the cutting edge advanced reactor designs have been there, which is having the versatility in an unprecedented level. They are highly flexible, as I was also saying earlier, with in compared with the renewable energy generations, and much less expensive, and they burn waste as an energy resource. So even the waste they can again work on and walk away safe. So this is NuScale Power's advanced small modular reactor, which is just showing in this picture. And then similarly, there are different things which are coming up through the Nuclear Regulatory Commission of US, and they are targeted to become the nation's first advanced commercial SMR, the small modular reactor at that point. And this innovation or this kind of designs which is coming up from United States and other places of the world can be also coming up from it's also coming up from China, Russia, South Korea, and India is also taking part in similar points of interest, such that they can also make advanced heavy water reactors, which is working on thorium. And there is a three-stage nuclear program in which that one reactor is continuously feeding to the other reactor, and the waste of one reactor is basically acted as a fuel of the next reactor. So this is a three-stage nuclear program cycle of India, which is also a very important point. The Department of Energy in the US as well as the Department of Atomic Energy DAE in India, both are working in a very beautiful manner such that new technologies can be developed. Advanced manufacturing, as we know, the disrupting innovations doesn't just stop with the advanced reactor designs. So only the reactor designs also coming up with the advanced manufacturing. The way these technologies will be built are dramatically changing through the advanced manufacturing. And these energy policies are basically supporting this kind of technologies, which is like this BWX technology in in the Oak Ridge National Laboratory, and they are actually making some products through additive manufacturing, that is also known as 3D printing, and quickly they are making these modular reactors in 3D printing, and they're testing them, some very complex designs, and they're rapidly prototyped, as you all know that how the prototyping is done in 3D printing machines. And this is one of the computer design file of a nuclear component used for additive manufacturing in the right side, as shown. So this significantly reduce the time and money it will take for them to bring the new fuels and components to the market. Now, whenever we talk about design and we talk about manufacturing, basically they are supporting some new kind of fuels. The design of the fuels are also emerging, and the new advanced reactors emerge when the new fuels are being developed. New type of fuel structure, fuel clusters are coming up, which can enhance the operating temperature. They are very much efficient at higher temperatures, and the Department of Energy is basically supporting them. Like for this, X Energy is a company which is giving effort on the design and of this pebble fuel designed by X Energy, as you can see in the picture. The pebble type fuel which are coming up for the next generation. And Trisu is another company which is also making these Trisu fuels are resistant to extreme temperatures and well beyond the failure threshold of the current fuels. So a lot of work is happening on the fuel clusters, how the fuels are made, and the cladding is basically a you can say it's as a cover basically over the fuels, and which is protecting it from the environment. It is not allowing the inner fuels with the fuel powder which is there inside to react with the environment. So cladding is very, very important. So the type of cladding is also changing. The shape is changing. The fuel of the reactors was initially shaped as a long rectangular rod mostly, but that is the design is now changing to some kind of balls. This is pebble fuels. So this is a huge change. Why I remember that I went to BRC in 2007, 8, and 9, 10, I think, 2, 3 times, and I saw that there this type of fuels. I took one of the fuel rods, depleted fuel rods, of course, and it was length having around few fits, maybe 4 or 5 fits of the fuel rods. They were completely very slender. It's very thin. Fuel rods were there. It's just basically rod shaped, but that thing has changed now to this kind of ball shaped. So these are the new generation fuels, the fuel structures basically, because fuel structure has a lot to do with the reactions. The facility ensures this kind of facility ensures a strong production line to help these fuels, this kind of fuels made by this TRISO. There are different type of fuels like accident tolerant fuels. It's then produced by General Electrics, GE, and they call it as a global nuclear fuel. Then another company, Framatome, then Westinghouse, all of them are working with DOE, Atomic Energy Department of US, and the other places to make the accident tolerant fuels to in the market in the next 10 years. So this global nuclear fuel is currently testing in 2 versions in these places of Georgia, and they plan to deploy the lead test assemblies with the fuel of 2019. And Westinghouse as a whole, they are trying to make this design evolving throughout the years, throughout the research. And a share of intermittent renewables systems has increased in power grids to ensure a supply of low carbon energy in nuclear power plants, which are being this a hybrid system, which is called HES. This is another future innovations, which is called hybrid energy systems, where two things are combined, right? The power grid is basically taking one part from the renewable energy and one part from the uh, nuclear part energy. So these two plants are in a hybrid mode they are operating, and they're filling the gaps left by solar and wind electricity production. So that's how it is called a hybrid energy system, which is very important for the next future generations to work. And this nuclear versus with renewable, this HES, what I was saying, that hybrid energy system offer a powerful synergy combining the reliability and base load capacity of nuclear power plants with intermittent renewable sources. You see that they're combining the reliability and the base load capacity of nuclear power, because nuclear power is something which will be giving you energy throughout decades continuously without stoppage, and that thing will always provide you the base load. If you have the idea of base load, the base load is a load which doesn't reduce throughout the day, a minimum load which is always needed, minimum electricity load which is always needed continuously throughout the day, throughout the year, throughout the months, throughout the year, throughout the weeks. So that is called the base load, below which the demand never falls. So that base load can be given by nuclear power, while the other power energy demands, like in the evening, you need some higher loads. Some places you need, some cities you need a higher load at some times. So those loads, which can be attributed by the renewable energy sources at various places. So this kind of combined grid system and the innovative work on them may really change the future of the energy. So this integrated approach is very important for low carbon energy future. So I'm very close to the end of this place, but I would just like to show you two videos so that you get some idea about the nuclear power plant, how they work. So first video I'm going to show you on this one, which is basically reactor in MIT. So I'm just running it. Is it okay? I would just like to the authorities whether is it okay to run the video?
Yes, sir.
Hello? Yeah. So this video will give you the understanding of how safe a reactor works. Acha, is it the sound is coming up or not?
Oh, sir, the video is also not playing.
Uh, oh my God, there's so many. Acha, the video sound is coming.
No, sir, it's not playing.
It's not coming. Oh, then it is a problem. Okay, so I'd like to just describe to some extent.
Sure.
So this is a city, as you see, in MIT. Can you see this is inside a city? Can you? Hello?
Sir, I think we can see the video.
Okay. I could not share the whole screen, right? Sorry. So I need to reshare again. Stop share and reshare the screen. The entire screen option is not coming. I don't know why. The entire screen option. It's a share sound is also coming. So optimize for video clip. Let's see whether it's coming.
Our nuclear research
Now the sound is
reactors in
coming?
the US
Yes, it's now it's
exists
audible and it's visible.
right here at MIT.
Yeah.
Yes, sir.
Is
Now
the
it's
sound
audible.
now it is audible? Thank you.
Yes.
Okay. So
So
can you see
what's
that this is a reactor that we are talking about, a nuclear reactor, which is in the city? How many of you can imagine this situation? Can you see that playground and this race? This is kind of race. I see this is probably horse race, or I don't know what it is, but this is a playground over there, and it's continuous structures in front of that. And this is the reactor of MIT. That's Massachusetts
inside?
Institute of Technology.
Hi, I'm here for the tour.
Awesome, let's get you signed in.
So this is MIT Nuclear Reactor Outreach Coordinator.
Take this.
What is this?
It's a dosimeter.
Oh, cool. Okay, thanks.
No problem.
Dosimeter.
Sarah, they're all set. Hey.
Hey, Sarah.
So this is the reactor superintendent.
Wait, what's that? What's that?
Oh, that's my light that I turn on to let everybody know that I'm in the lab.
Oh, cool. Okay.
So what you might not realize is that the reactor has very specialized parts, and if something breaks or something needs to be replaced as preventative maintenance, we can't just get a catalog and order a new part. We have to actually rebuild it from scratch. So this is why.
So they cannot afford, wastage of anything. Everything can be made.
We need machine shops here on site.
So this is where you do that.
Yes.
Bye, PJ. Bye.
I got started when I was a freshman in undergrad. I was hired as a part-time student operator, and I stayed through all my years at MIT and through grad school at MIT, and now I work full-time here. All right, let's keep going.
Okay. Why is there this big imposing door?
So the containment building is airtight, and this way any air that is going to leave the building goes past detectors and filters to make sure that we're not putting radioactive material into the atmosphere in Cambridge.
So right now we are trapped.
No.
Okay, so this is where the power is made, right?
No, this is a research reactor, so we don't actually generate any electricity. We make lots of neutrons, which we use for experiments, and actually we're the second highest power level research reactor on a university campus in the US.
Oh, cool. How come it's so noisy in here?
We have a lot of instrumentation running around us. We have some radiation detectors, so there's an air monitor here. And we also have an area monitor on the wall up there. And these help us to know what the radiation level is around us as we work. Because our body has no way of sensing radiation. It's not something that we can detect as human beings, so we have to have instrumentation to help us out.
How much is that? What does the 0.1 mean?
So it says 0.1 right now, and that's the reading in millirem per hour, which is a unit of radiation per unit time. And to put things in perspective, you get about 1 millirem per day living in Boston from back.
Just look at this point that inside this MIT reactor, when the radiation level is judged by the instrument, and the level of radiation inside this reactor is 0.1 millirem per hour. At this point, when they have not entered, but at this point, inside the reactor building they are. And in the Boston city, the rate of energy, the rate of radiation outside this reactor is around 1 millirem per day. And this is 0.1 millirem per hour. So you can have some calculations of what is happening.
Background radiation from space and from granite rock in the ground.
Let me get this straight. We're standing 14 feet away from the core of a nuclear reactor, and the amount of radiation we're getting is the same as if we were standing on the street in Cambridge.
Correct.
How is that possible?
Concrete shielding, and I'll show you.
So this is the shielding technology that a lot of innovative works can be done in shielding part. And this shielding is such an amazing thing that even if they are at around 14 feet from the nuclear reactor in front of them, and they are still, the radiation level is so much in control.
So this is the outside of the shielding around the reactor core.
So this big cylinder of blue thing here?
Yeah, this light blue cylinder that you see here. And it's about 5.5 feet thick concrete shielding that's heavy, dense concrete, so it's got metal punchings in it as well as sand and water that makes it better for absorbing radiation.
So it's not regular concrete?
Yeah, it's special concrete.
Nothing is regular in a nuclear reactor?
No. And that's where the nuclear reactions are taking place. So the fuel is loaded into the reactor core, and the uranium-235 atoms are splitting, which releases some neutrons, and those get absorbed by other uranium-235 atoms, which split and release more neutrons. So all the neutrons that we use come from the core here. Hey, Paul.
Hey, Sarah. So what's Paul doing, Sarah?
Paul's going to load some silicon into our silicon irradiation facility. So one of the things that we do here at the reactor is we irradiate silicon to be used as semiconductors. So silicon by itself is not a good conductor, but by irradiating it with neutrons in our reactor, we can change some of the silicon atoms to phosphorus atoms, which is called doping. So we dope the silicon material so that it has a distribution of impurities that cause it to become a semiconductor. So semiconductors can be used in all kinds of electronic applications, but the way that we irradiate silicon here means that we can be very precise. So the silicon that we produce here ends up in very critical applications such as airplanes and the power grid. Let's go see the reactor top.
Okay, let's go.
So this morning we're installing the new SALT experiment that we've been working on for several months. And this experiment will stay in the core for 1,000 hours to be irradiated by neutrons.
Let's go. This is the place where the tours normally stop.
Yes, that's right.
And you're gonna let me go past it.
Just you.
So what do I need to wear?
So I'll show you what to do.
Okay.
You need to grab some rubber booties and put them on your shoes.
Okay, now I step over here.
Yep.
Okay, and so my other shoe is still back here.
Yep.
And then I get the other one.
Yep. Anyone, they're not pairs. So we duct tape our pockets closed on the reactor top area because that way we can't be tempted to put objects in our pockets and then lean over the core and have them fall out.
So we don't want stuff to fall into the core.
No. It's very difficult to fish things out of the core and it could damage the fuel, which is a risk that we just don't want to take.
Has anything ever fallen into the core? Have you ever dropped anything in the core?
I have not dropped anything in the core. Do you mind if I put this on you?
Yeah, go for it.
So here now you can see the nuclear reactor core, which is open in front of you.
So can I take a peek in the core?
Yes, you can take a peek in the core.
It should be closed when the grid is being closed.
The core is shaped like a hexagon, and it's made up of 27 diamond shapes.
Now you can see the nuclear reactor core itself in front of your eyes, and you can see the people all over there is looking at that, and they're doing some experiments on that. See, this is a situation where you can try to think that when people are, in fear of nuclear power, then people are who are in the research, who are doing job over there, how they're acting with this situation, and how they're having definitely some rules and regulations they are maintaining in cautions. But what is the actual scenario? It's very much
That fit together to make a hexagon, and each of those diamond shapes is a fuel element. One of those diamonds is going to hold a cylinder, which we're using to hold a special salt that could be used in the future to cool down nuclear reactors. The reactor.
They are trying to find out some special salts which can be used for further cooling. The cooling down of the reactors can be used by salts. So they are trying to use that experiment in that point.
It's a really good tool for testing materials because the core itself is an extremely harsh environment. There's very high levels of radiation, and we can heat the experiment to really high temperatures to really stress test the material.
So we're standing 5 feet away from an open nuclear reactor core. How are we not dead?
So in the core tank we have.
That's the best question that people will ask, that how we are not dead, when we are 5 feet from the reactor core.
10 feet of water between the top of the fuel and the top of the water level. And the purpose that serves is to shield us from radiation when we're working in the core, and it also serves as a reservoir for cooling.
So 10 feet of water is enough to get the dose from thousands of rem per second to 10 millirems per hour?
Yep.
It's kind of insane.
So thousands of rems per second to 10 rems, millirem per hour. This kind of transition can be done by the 10 feet of water. That is the most amazing part of this video that I would like to show you. Let's go on.
Why is water so good?
Water is really good at absorbing neutrons.
Water is a very important thing which is good for absorbing neutrons, and also it do the moderation of inside the nuclear power. It slows down the neutrons such that the thermal reactors may work on. Thermal reactors means which is working on certain band of energy. And you see that there are so many places in which people can start working and do research and innovations in this way.
Success. Guess we're ready for the next step.
So the first thing we do is take our gloves off. Put them in the trash.
Can you help me?
Yeah.
I think it's maybe a, yeah.
So this is one of our neutron beams that you can use to do experiments outside the reactor. So the neutrons come from the reactor along this beam line, and you place your experiment sample on the beam line and detectors, and you can do the experiment here. So right now Gordon's explaining to his students how they're going to use the neutron beam for their lab class, for their experiment. And so the students can set up their experiment here on the beam line, and then they can collect the data that they need completely remotely from their dorm room.
So students at MIT can actually do experiments at the reactor?
Yeah. We have a lot of student participation here at the reactor.
So what kind of experiments do students do with the neutron beam?
So you can calculate the reactor's power level based on the speed that the neutrons are traveling. You can figure out how good a material is at absorbing neutrons, and you can also figure out the shape of molecules based on the way neutrons bounce off them.
Hey, that's...
You can see a lot of projects for students in MIT, how they're directly involved in.
pretty awesome.
All right, next.
Yes.
So this is Mike, and he's one of the experimenters working in the hot box.
Hey, Mike. What you working on?
So what we're doing here is we're disassembling experiments that have been in the core of the reactor, in this shielded box. So the hot box is useful for storing and handling materials that have come out of the reactor. They need to go in here because they're too radioactive to handle close up, but we can handle them inside here because of the lead shielding in the walls here.
How much radiation are we talking here?
So the radiation levels inside the hot box are about 30,000 times higher than they are out here.
So you can just look, this kind of shielding 30,000 times higher inside the box than the outside the box. This is the level of radiation change difference, and how people are very smoothly working on it.
Here. And so that's why we have samples and the materials that we've taken out of the reactor inside here. But we can work on them safely using these.
And these robotic manipulators are there, which are, it's a big thing nowadays. Everybody's coming up with these manipulators, these actuators design.
So what's that sample?
The sample I've got there is a piece of silicon carbide with a chromium layer on the inside. And it's a potential replacement for current reactor.
I was talking about the cladding. The cladding material is a very, very important part, which is actually separating the outer ambience with the actual fuel. The fuel that you see in the picture, even in the pebble weight fuel that I showed you, there is a outer layer basically that you see is called cladding. Sometimes it shines, it is made of steel. Sometimes there are other very different materials by which the cladding is done. So they are trying to find out some new potential element for the reactor cladding.
And so we're testing it to see how well it does under radiation and temperature and conditions typical for a power reactor.
I have a question for you.
Sure.
Can I try?
Yes, you can.
Wait, really?
Oh, of course.
I never get to do this. What is this?
Actually, we've got a little poly vial in there. Sometimes the trickiest thing is closing the lids on the vials.
It's a competition. Cool, thanks, Mike. See ya. Hey, Tom.
Hey, Sarah.
Tom's making gold radioactive for medicine.
Wait, what?
See, this is a part where they are working on medicines. The radioactivity, as you have seen probably at nuclear medicines, are a part of research. A lot of people are doing research on nuclear medicine. So this is one of the just connection that I'm just showing you.
So we were actually going to be taking some gold pellets and using a rabbit, insert them into the reactor into an area with a lot of neutrons. And the neutrons will make the gold radioactive. So when the sample comes out, we can then ship it to a hospital where they can eject them into a tumor in order to cause radiation damage directly to that tumor.
So wait, what about rabbits?
So they're not real rabbits. We have these poly sample holders where we put the gold directly into.
So you put the gold in the rabbit and then...
So the rabbit would go from where we inserted it through this tube and into the reactor. And then when it's finished, it will come down the tube and out into our shielded hot cell. So when the material's radioactive, the radiation is all contained inside of our shielded area to work with.
Okay, see you, Tom. Let's go to the next stop.
Okay.
So we're about to enter the control room, and the control panel is on the right, so please try to keep on the left.
So I shouldn't push any buttons, right?
No. Hey guys. So this is the control room, and the most important thing in the control room is the operator, who is Sarah right now. Sarah is actually a student operator, and Paul is the shift supervisor currently. So right now they're working on the startup checklist to start the reactor back up.
Cool. Weren't you doing something with silicon earlier?
I was indeed.
But you finished.
I finished that.
And now you're here.
Correct.
Isn't it weird how one person can move from one place to another? Do you have a favorite button?
Yes.
That's the most, a funny question. Do you have a favorite button? So which one?
Wow, that's a good question.
This is
the major scram button, which I've only ever pressed during testing. Never actually had to major scram. It's one of our emergency shutdown buttons, and it automatically drops all the control blades in, and it isolates our ventilation in case something were to get out. But I just like it because it's the big stereotypical red button in the reactor.
Do you know what every single one of all of these buttons do?
Yes. Some of the experimental ones, I wasn't covered in my training because I don't have to run the experiments, but all of the regular operations ones.
Quiz time.
What is high temp D2O reflector cleanup system?
So the reflector system with heavy water has a cleanup loop where it flows through an ion column, and if the water gets above 50 degrees, it could potentially damage the resin in the ion column, so that alarm will go off to tell you that you need to cool it down or you need to bypass it.
What does DP3 30 PSIG mean?
So that's one of our pressure gauges for our heavy water system. That's what the D means. That tells you reflector system, the P is pressure, and then 3 is just the number demarcating it.
What's this gauge do?
This is for auto control. So using this gauge here, you can set your auto control to tell the reactor this is the power I want to stay at. And this gives you the percent deviation. So if you're too high or low, that needle will tell you. You want to keep it at 0.
What's this knob?
So we have 6 different shim blades, and you can only move one at a time. So this is to select which one you want. So right now 3 is selected.
Okay.
But you can turn it, and you can pick a different blade, just whichever one you want to move.
What is this?
This is the official console clock.
So you're a student, you said?
I am a student.
Okay, what year are you?
I am a sophomore.
So you're a sophomore at MIT?
Yes.
And you are running a nuclear reactor?
Yes.
That's pretty freaking awesome. Okay, so what kind of training do you have to go through to be able to sit at this console?
So there's a lot of studying through systems manuals, technical specifications, all the alarms and procedures, and then there's hands-on training where you come and you sit training watches and you'll perform practice. We fly in and I'll give her a tour in all areas. Guys are in the control room with you, but I can perform all the operation duties in here alone.
All right. Thanks, guys. See you.
So this is looking for contamination.
So this is a point where before going out of the reactor, they check their radiation level. And ultimately, this is the point of importance, how much of radiation they have carried. So this is the last part. I think somebody has been unmuted and all.
And what happens if it's not? Like, what do you do if it says dirty?
Well, first it'll tell you where.
Oh,
So
okay.
that helps, right? If it's your left toe or your right hand. It's usually pretty low levels, so to get the contamination off, think of it like dust. And so you use tape. We'll have light hand washing. And usually it's as simple as something on a lab coat cuff, say, that somebody has been working with a contaminated sample. And we'll just take that lab coat and put it in our laundry facility and get it clean.
This looks like, you know that thing from the movie Interstellar?
Yes,
You know,
I love it. Yeah.
What's
TARS.
TARS.
Yeah.
That looks like TARS.
আজকাল তো সব টিনেজাররা ইউজ করে আমার মেয়ের জন্য ওকে ডেভেলপ শিখার তো বয়স বেশি নয় 12 বডিটা ডেভেলপ হলে 2 লাখ সিঙ্গার তখন থেকে ওকেটা না করানো মুশকিল
These are both backups that monitor where to malfunction.
খেলাধুলো করে ক্যারাটে থেকে লাগে আর
Okay, thanks for the tour, Sarah.
No worries. There's one more thing we have to do, though. I have to get your decimeter back.
Oh, right. There you go.
Thank you. So it's really...
Okay, so wait a second. We just spent all day inside a nuclear reactor, and the radiation dose has not changed at all.
So this is a point where, the video ends, and it shows that even after spending such a long time in the nuclear reactor, the dosimeter whatever reading is there,
Thanks for coming.
is not changing, and it's almost the same when it was entering. So why I showed you this video is like to understand what kind of situations persist in a nuclear reactor and how things work and how people, the students are actually involved in various places around the world. They are doing research, they're doing innovations in that field. And at least we may not have the big reactors inside our universities, but at least we can try start thinking or do some work on this part also in a sector of for as in the perspective of innovation, the perspective of research, and try to develop some of the a small contribution at least to really make our future green in all perspectives. And almost at the end of my session, and I'm just showing you 1 minute of this small one. This is a very small video, but I'm just showing you the most advanced nuclear reactor at this point is actually this. This is a fusion reactor. I'm just going to give you just one view of fusion reactor and how it looks.
सुन रहा हूँ
4, 3,
ओ
2,
बुआ के लिए
1.
शोपीस लेकिन पिंकी ने तो टॉप्स मांगे
Yeah.
This is where they are building the largest nuclear fusion reactor in the world. Right now, I am inside the assembly hall of the International Thermonuclear Experimental Reactor in the south of France. And just behind me back there is where scientists and engineers are working to replicate what happens inside the sun.
So this is the thermonuclear reactor, basically, which makes the 1 minute.
Now, this is so much more than just another energy project. It's a $22 billion science experiment between a whole host of nations all coming together to try and change how we generate power on this planet.
ITER's mission to create a new carbon-free energy source couldn't be more urgent. Global energy use is projected to nearly double by 2050, and we've got to drastically cut our use of fossil fuels. Some scientists hope that controlled nuclear fusion could be the holy grail of energy, but there's a catch. As it stands right now, no reactor has ever been able to produce more energy through nuclear fusion than it takes in. ITER's aiming to be the first, and if it's a success, it could quite literally change the world.
So I hope you have got a glimpse of the thermonuclear reactor, which makes the basis of hydrogen fuel. If you think in a perspective of destruction, you will think about hydrogen bomb, nuclear bomb, and all. But if you think in the perspective of development of the whole nation, development of for a sustainable future, then a lot of things are there to explore. A lot of things are there to understand and grow in this sector of nuclear technology. So I hope I have given you a little different thinking perspective. And I wish that you also explore this kind of things in your sessions, in your careers. So with this, I would like to end my session. Thank you very much. If you have any queries or comments, please. Was I was yeah, I was audible throughout the session, or sometimes there was some problem?
Yes, sir, you were audible.
Okay.
The participants are requested to ask questions if they have any, or make comments, or give a feedback to, or just have an interaction with sir.
Yeah, it's open. You just have some chit chats, that will be okay. I understand this is a zone of interest which many are not attached with, but it's not a regular thing that people deal with. But always you have a scope of exploring things out of the box. So any question from anyone? A little bit of voice could be useful from any one of you rather than comments in the message box.
Yes. Does anyone have any
Yeah.
queries, or does anyone want to interact with the speaker, with Professor Ghosh?
What do you think about the nuclear sector of in India? Now, how you feel? You know, someday earlier, I used to think that a few years back, I used to think that if there is one reactor every 2-3 states, basically, we don't need to think about power at all. Anything we can do. So I hope if you have any questions or any queries, if you just want to have a chit chat, no problem. Any comments, please. Well, by the way, are you there, all of you? I don't know, 45 people are there, 46. I understand many of you might be busy in some other works, but those who have heard this lecture, if you have anything to share from your mind, you can please. Yeah. Rajesh is saying always there. Yeah, others are there. You are from the college itself. All participants from college or some people from outside also?
No, sir. There are people from outside.
Yeah.
So
Okay.
I
Yeah.
think, yeah.
Mm.
Okay. So I'd love to request one of the chair of the session to share the appreciation certificate for Dr. Shondeep Ghosh, sir, Professor Dr. Shondeep Ghosh, sir. Thank you so much, sir, for your wonderful session.
Thank you very much. By the way, have you shared anything in the screen? I don't know.
I don't think they have yet.
Okay.
Yes,
Yeah,
it is
yeah.
shared now.
Okay.
Sir, please take it from our end. Thank you for being here. Thank you for holding this absolutely amazing session.
Thank you very much. Thank you very much. Thanks for giving the opportunity.
Yes.
Okay, so with your permission, I'm leaving the session. Thank you.
Yes, sir. We will be mailing you the certificate. Okay.
No problem. Okay, okay.
Okay, sir.
Thank you. Thank you.
Okay,
Thank
sir.
you.
Okay.
Goodbye, everyone.
Thank you, sir.
Bye, sir.
Thank you.
Thank you, sir. And all the participants are requested to fill up the assignment and attendance and feedback form, which is shared in the WhatsApp, or will be shared in the chat WhatsApp chat group. And we will continue our afternoon session from 2 p.m. onwards. Please join on 1:50 p.m. And thank you for joining in the morning session. Okay, I think we can call it off.
Yes, sure. Now I just shared the feedback link and as well as attendance link and assignment link in live session as well as WhatsApp. Okay, see you from 1:50 p.m. and our next session starts from 2 p.m.
See you at 1:50 p.m. everyone. Okay. We can end the meeting, sir. We can end the meeting.
Thank you, ma'am. Thank you, sir.
Thank you.
যদি কেউ ফোন করে পারলে ভোট দিন করে বলে দিবি সব ক্লাসে যাচ্ছে
শুভাশিসের স্ক্রিন শেয়ারিং হচ্ছে? না না এখানে
Sir, has the host joined? Has the speaker joined?
No, 200 madam. Our speaker will join within 5 minutes. I already
Okay,
communicated with you. Within
Okay,
5
sir.
minutes, our
Okay,
speaker.
sir.
Good afternoon, sir.
Yes, I'm audible. Good afternoon.
Good afternoon,
Yes, sir. Shubhanurekha madam, our honorable speaker will already join. Please start our session.
Okay, sir. Good afternoon, everyone. Welcome to the last session of the 5-day FDP program. Thank you for joining in each session over Zoom. Now, in the last session, we have Dr. Vishwarup Niyogi. Dr. Vishwarup Niyogi presently attached with JIS College of Engineering as a Dean Research and Development and Professor of ECE Department, in addition as a President of Institution Innovation Council under Ministry of Education, Government of India. As an Innovation Ambassador, Institutional Innovation Cell, he is enhancing the innovation activities in GISCE and propagate this activity in society. He is associated as a mentor of 0 to ATL Lab under Atal Innovation Mission NITI Ayog. He also received visiting scientist post from Institute of Coal, Federal Research Center Coal and Coal Chemistry Siberian Branch, Russian Academy of Science. He is the executive council member of Makout. Due to his patent number and research, he was awarded GIS Samman in his institute. Due to this reason, he was also awarded Bongo Gaurav Samman on the year of 2022. He also achieved several awards in national level. His innovative projects mainly focuses on the solution creation of Divyang and grassroots level problem solution for India. He is networking with several budding innovators and engineers in all over India. Mainly, he is trying to create one ecosystem for innovation and entrepreneurship by developing one network with young innovators in India. He is purely acting as a significant role in case of Atmanirbhar Bharat Abhiyan for our motherland. Sir, the session is handed over to you. You can go on. You can begin your session.
Thank you very much. I think I'm audible to everybody. So
Yes, sir, you are audible.
okay. The thing is that first of all, thank you very much, GKCEM, for giving me this opportunity. I'm just not taking too much time and going to my presentation session. Well, so basically today my topic is quite interesting. I think you get the interest on this particular that the measurement of innovativeness and startup not for the engineering product. Basically, we are working on the different activity on the purpose of our innovations. I think we know that innovations till now we have already aware about that. But how we can measure the innovativeness of any kinds of program and how we can launch in the startup and what is actually we are developing several products, several projects, but we are not measuring the proper innovations. That is very much mandatory right now in India. And on that aspect, our my presentations is related to this. First of all, thank you very much, GKCEM, for giving me this opportunity in this FGP as a speaker. Thank you, Mehua Madam, who is present here, and thank you the convener and coordinators, who is very continuously connected with me. And I'm very much busy soon on my busy schedule here, several times connect and make it feasible. Now, in my topic today, there is a three terminologies are very important. One is the measurement of the innovativeness. Another is the startup learn. Another is the innovative engineering program. We know that these type of presentations, as beginning, I'm always giving my namaskar to APJ Abdul Kalam. His quote, everybody knows about this particular quote, and also Steve Jobs for distinguish between the leader and followers, leaders, and if you have the capability of the innovations. Right now, this is the terminology all over the world, that innovations. You have the capability, if you have the creativity, you have the capability of the innovations, then you are becoming leaders. But in MIT, what is actually innovations? First, we have to know that innovations, what is innovation? Then I can understand. According to MIT, innovations is representing in a mathematical way. That if this is the innovations, I think we show my cursor, then the idea which is multiplying with the commercialization, then it is only the innovation. Suppose if you have any idea, but it cannot be commercialized, it is only idea and idea, then the commercialization part is zero. So the innovations is zero. The total part will be multiplying with the zero, then it is becoming zero. If in your commerce business, there is no any idea, new kinds of idea, then the idea part is zero. This is only the commerce part, commercialization business part. Then when it is multiplying, then also the innovations become zero. So innovations is basically idea and commercialization. Commercialization means it can generate some revenue by anyone, by any kinds of process. It can able to generate some revenue. Then it is called the commercialization idea. Now, type of the innovations according to MIT, I'm saying that it is the three types: technology, process, and business model. I think you know about this particular picture, that by a certain time, a good night first launch this type of things. In that case, there is several problems. Matches jalo re, usko कुछ जगह में रखो रे, उसके बाद उसको आग लग जा सकता है. So there is some problem. So good night is introduced one thing, only on the switch there is a refill, and then the mosquito is not present in your room. So this is a problem. These are the problem is there, and that can be overcome by this. So very simple technology you show. Simple technology they are used. That is called the innovation. That is the technological innovation. Next, you show there is a type of the innovation, technology, process, and the business. I'm explaining this is the technological innovations. Okay, right. Now the process innovations. Process innovations, I think you know about this particular queue. It's in the Howrah station. For the getting of taxi. It's the queue for the taxi. Okay. But that at right now, our hand, Uber, Ola, and also Rapido for one single person. So this type of facility is coming. If you go for another example for the process innovation, that means this process is technologically solved by this. That is the process innovation. By this process, we can very easily adopt. Okay. Now another process innovations are what can I say that phone pay, GPay. पहले कुछ दुकान में जाकर छुट्टा नहीं है, ये नहीं है, वो नहीं है, ये पैसा ले नहीं सकती, ये पैसा प्रॉब्लम है. You just digitalization during the COVID and everything is coming in the QR code. आप पान की दुकान में जाओगे, चाय की दुकान में जाओगे, कोई भी जाओगे, only 5 rupees you want to pay. That is also you can able to pay by using this QR. Okay, so that is also the process types of innovation. That banking process, transaction process, the monetary transaction process is totally become technologically support and it's becoming very easy. And now another things I am giving you the example. This is a business model in innovation. There is a 3 types of innovations. I am saying the business model innovations is if you go for the Geo, that when Geo is coming in the market, I think you know about that. Everybody, we are taking the Geo because this is a free. Okay. After then, they are gradually increasing the facts, increasing the revenue, increasing the monetary fact, the recharge, ये recharge, वो recharge करके अभी तो और भी ज़्यादा बढ़ने वाला, enhance करने वाला. So right now we are entering the Geo family. We cannot be possible to because this is also very nice innovation. We are entering inside of the Geo innovation process. Okay, so this is a business model types of innovations. Okay, पहले आपको कुछ free देने का मतलब है you are entering in the facts. Okay, so that is a very important fact. Now, I think it's in your mind that sir, you are saying that different types of innovations. So how we can thinking about that? The thinking process. There is a 3 questions I am explaining. First question is that what is happening in our surrounding? क्या हो रहा है? तीनों क्वेश्चन माइंड से पूछो. Okay, आपको इनोवेशन आ जाएगा. What is happening in our surrounding? What the problem is present? What the problem is in present age for our society? क्या problem है society में? Next one, what is the commodity is necessary for in the present age? If you think properly, these 3 questions asking to you yourself, then you can understand the what kinds of things you want to innovate, you need to know. Okay. Now startup is very make something people want. Make something people want. Startup means make something people want. और कुछ नहीं. Make something people want. यही startup है. कुछ भी करो जो people का जरूरत है. That is the make something people want. And ये वांट जितना ज्यादा होगा उतना आपका अच्छा स्टार्टअप होगा. ठीक है. Now government of India given 10 real problem in India. If you go for any kinds of startup to solutions to give the solution of this particular problem, then you definitely get the fund. There are several types of fund is there. If you go for bank, Mudra is there. Apart from that, you can search in Google now. Everywhere there is some hackathon and that kinds of things is happening. And we are lagging basically. We are not adopting all this fund. हम लोग फंड नहीं ले रहा है। यस, फंड लेकर बैठे है गवर्नमेंट, फंड लेकर बैठे है बहुत सारा लोग, लेकिन वी आर नॉट प्रिपेयर आवरसेल्फ टू गेटिंग द फंड। हमारा कॉन्सेप्ट क्या है, चलो भाई जॉब करो, जल्दी से जल्दी जॉब करो, ठीक है। तो आज हम लोग सीखेंगे कि कैसे हमको ये ओवरकम करके जा सकते हैं उसमें, ठीक है। तो आई एम गिविंग यू 10 प्रॉब्लम as we are the engineer, as we are teacher, as uh, we are also in others profession, entrepreneurs. So it is our mandatory to know what are the 10 basic problem in all over India. First is the instant access of healthcare. गांव में चले जाओ, नहीं है, एक्सेस नहीं है। आप यहाँ से कुछ लोग गांव से है, I know that they have, I know that in your locality it is too much far from your positions to the instant healthcare system. कोई डॉक्टर नहीं है आपके घर के नजदीक, ठीक है। पब्लिक ट्रांसपोर्ट, दिस इज अ वेरी इंपॉर्टेंट प्रॉब्लम। आप गांव में चले जाओ, कुछ जगह में चले जाओ, ट्रेन बोनगा लोकल, this is the problem, this type of problem is there. Still now we are not thinking about that. Yes, we are not thinking about that. Now sanitation, pollution, वेस्ट मैनेजमेंट, वेस्ट, ये देखो ये प्लास्टिक वाला क्या कर रहा है, ये प्लास्टिक बोतल मैं ही यूज कर रहा हूँ, मैं भी यूज कर रहा हूँ, ये देखो मैं भी यूज कर रहा हूँ, मैं भी यूज कर रहा हूँ। कुछ कर नहीं सकती यार, कुछ ना कुछ करो, कुछ ना कुछ डेवलप करो इसको ओवरकम करने के लिए। तो these are the problem is arise. Now easy access to the quality education. आप गांव में चले जाओ, इस तरह से बैठकर पढ़ते हैं। हमारा इंजीनियरिंग कॉलेज में क्या होता है, यार एसी घर है, क्लीन क्लासरूम है, बहुत सारा फैन लगा हुआ है, लाइट लगा हुआ है, ये देखो कैसे पढ़ रहा है। इलेक्ट्रिसिटी प्रॉब्लम, दैट प्रॉब्लम इज आल्सो अराइज, द इलेक्ट्रिसिटी प्रॉब्लम टिल नाउ। ये देखो हरिकेन लेकर पढ़ रहा है, तो देखो क्या प्रॉब्लम। क्राइम, बहुत ज्यादा क्राइम बढ़ रहा है। सेफ्टी ऑफ द वुमेन, एक्सेस ऑफ द क्लीनिंग ड्रिंकिंग वाटर। कुछ दिन रुक जाओ यार, कलकत्ते में भी ये प्रॉब्लम आ जाएंगे, बेंगलोर में तो आ गए, ठीक है, साउथ इंडिया में ऑलरेडी ये आ गए और कलकत्ता में भी आ जाएंगे, access of cleaning water. Okay, so these are the 10 problem which is very much essential. ये देखो हमारा स्टूडेंट लोग क्या करते हैं, ये देखो ये यहाँ पर लाइन देकर हुआ है, कोई PCS और CTS का कोई जॉब इंटरव्यू है, वो यहाँ पर लाइन लगा हुआ है कि 4000 स्टूडेंट्स फॉर जॉब इंटरव्यू, 40 नंबर्स ऑफ जॉब। ये 40 नंबर जॉब के लिए 4000 स्टूडेंट, 40,000 स्टूडेंट्स आर फाइटिंग। If our 40 students establishing the startup, then each startup will create 100 job ना, कुछ ना कुछ हो जाएंगे। अरे 100 नहीं, 10 जॉब क्रिएट करो, बहुत सारा कुछ हो जाएगा। लेकिन हम लोग करते नहीं है, हम लोग सोचते नहीं है, हमारा माइंडसेट वैसा नहीं है। क्यों नहीं करते? लेकिन हमारा जो मंत्र है, ये मंत्र आपको रहेंगे तो आपको पता चल जाएंगे कि इंडिया में स्टार्टअप करना बहुत सुविधा है। इंडिया में स्टार्टअप को लाना, इंडिया में स्टार्टअप एस्टैब्लिश करना बहुत सुविधा है। आपको दिखाऊंगा, ये देखो ये 2 मंत्र मैं बोल रहा हूँ, ये मेरा मंत्र नहीं है, ये बड़ा बड़ा स्टार्टअप एक्सीलरेटर जो है उनका मंत्र। आप देखोगे कि इंडिया में बिजनेस करने के लिए बाहर से बहुत सारा कंपनी आ रहा है, आउटसाइड ऑफ इंडिया। ऑस्ट्रेलिया से आ रहा है, यूएसए से आ रहा है, जापान यहाँ पर बिजनेस करने चाह रहा है, फ्रांस यहाँ पर बिजनेस करने आ रहा है। आई डोंट नो व्हाई दे आर इंटरेस्टेड, बिकॉज द इंडियन मार्केट और द इंडियन मार्केट। आप देखो ये आप रिक्स, आप जब स्टार्टअप के बाद आओगे तो आपको ये बात में आ गया, अरे रिक्स बहुत रात तो बोल के खलास होके चले जाएंगे, ठीक है, लेकिन रिक्स कौन संभालेंगे? लेकिन the mantra is that 2 months I am giving. The populations of the India is very high. If you can develop your product properly and proper product and go to address the proper crowd, इंडिया में जहां पर ये स्टार्टअप का जरूरत है, आपका प्रोडक्ट का जरूरत है, आपका सर्विस का जरूरत है, उस जगह में जाओ। If you can visit and if you can sell your product or if you can express your product on that case, definitely your product becoming becoming positive bias. Okay, definitely your product becoming booming product. Okay, it's becoming an innovative startup. Okay, now another things, जैसे भी हो सके आप जो स्टार्टअप कर रहे हो वो स्टार्टअप को आप 5 years जैसे भी हो सके 5 years आप उसको रन करें, जैसे भी हो सके कुछ ना कुछ करते रहो, कुछ ना कुछ करते रहो। ऐसा नहीं कि आपको कंपनी ओपन करके लैब के अंदर जाके सो गए, ऐसा नहीं। आपको कुछ ना कुछ एवरीडे करना है स्टार्टअप के लिए, आपका प्रोडक्ट के लिए, तब आपको हो जाए। ठीक है, तो मैं बहुत ज्यादा टाइम ले लेता हूँ, आई एम सॉरी फॉर दैट। नेक्स्ट, so there is a one success mantra, that is the agility and stability. ये एक सीढ़ी की तरह है, सीढ़ी, agility कुछ करते रहो and stability, agility and stability सीढ़ी की तरह है। सीढ़ी जो होता है ना, सीढ़ी की तरह, staircase, ये agility and stability ऐसे करते रहो, आपको आपका स्टार्टअप ऑटोमेटिकली हो जाएगा। There is one very important thing, that you have a good character. The one startup entrepreneurs का क्या character होता है? Be trusted and honest personality, be good human beings, be decided to hardworking to image, explore the unique idea, networking with the school, college. ये networking एक बहुत अच्छा चीज है. It's a very interesting चीज. Okay, you have to think about that, the network. Now, this is my another part, how to collect fund for the startup. That is, there is a 40 to 50 numbers of government funding agency you can very easily start up. This is another sector of my presentations. I am not elaborating these things today, but you can show there is several announcement of the government, but we are not aware about that. We are not able to get the fund properly. You show several number funding facility in the government, several. Okay. Now coming to my main topic, that is a measurement of the innovativeness, measurement of innovativeness of any idea. So process 1.0, I am fast explaining the process 1.0. ये process 1.0 बहुत तगड़ा process है। Okay, ये process से आपको क्या होगा, आपको पता चल जाएगा कि आपका स्टार्टअप और आपका जो आइडिया है ये जबरदस्त है या नहीं। Again I am saying, आपका जो आइडिया है ये आइडिया जबरदस्त है या नहीं, इसमें आपका आइडिया मार्केट में आने से अच्छा होगा या नहीं होगा। Your idea, if you can launch in the market, this idea is becoming this idea is giving you outcome, or your idea is fake. Okay, so that is very much necessary to understand. For that reasons, what we are doing, we are not developing our product first, but we can make it very artificially. We can make it a interesting way, representing it interesting way. First, what we are doing, that I think as a faculty member or as a entrepreneurs, or if you can technical staff, whatever, I think you have several ideas. If you think, sir, I think you can ask me, the Dr. Niyogi, you can say, I have several ideas. I have several ideas in my mind, but I cannot identify which idea is the best. Okay, ये आप नहीं बोल पाओ, ये आपका जो सेल करने से आपको जो चीज खरीदेंगे वो बोलते हैं। Okay, कि आपका कस्टमर ही आपको आइडेंटिफाई कर देंगे कि what is actually the concept of the startup, what is actually your मेल प्रोडक्ट, कौन सा प्रोडक्ट लेकर आपको आना है। तो फर्स्ट स्टेप 1, यू राइट डाउन ऑल ऑफ योर आइडिया। अभी ये जो एफडीपी हो रहा है ये ऑनलाइन में हो रहा है, लेकिन व्हेन इफ आई एम कमिंग इन फ्रंट ऑफ फिजिकली, मैं आपको इससे कराऊंगा कि यू राइट डाउन ऑल द आइडियाज, व्हाटएवर द आइडिया यू हैव, यू जस्ट फर्स्ट ऑफ ऑल राइट डाउन। ओके, आप लिख सकते हैं, आप जो ऑनलाइन में देख रहे हो वो लिख सकते हैं ऑल द आइडिया। नेक्स्ट, ईच एंड एवरी आइडिया का यू जस्ट मेक वन बिजनेस नेम। बिजनेस नेम क्या है? बिजनेस नेम इज द डिफरेंट। ओके, बिजनेस नेम क्या है ये देखो, ये यूडेमी बिजनेस नेम है, फेसबुक बिजनेस नेम है, लिंक्डइन बिजनेस नेम, लिंक्डइन कहाँ से आ, लिंक्डइन लिंक करने का वो जैसे लिंक से, कोर्सेरा बिजनेस नेम, ये सब देखिए, ये सब बिजनेस नेम, कोको कोला बिजनेस नेम. Okay, so you can give according to your startup. हाँ, ये टेक वाला जो बिजनेस नेम में तो किया है, जो आपका बिजनेस नेम है वो बिजनेस नेम, कोई भी आपका जो स्टार्टअप है उसका एक बिजनेस नेम दे, ठीक है. जो भी आपका जो आप आइडिया दिया है वो सब एक बिजनेस नेम है. आप सपोज 5 आइडिया लिखा है तो 5 आइडिया का बिजनेस नेम. नेक्स्ट, अभी एक कुछ खर्चा कराऊंगा आपको, ठीक है. आप बुक ए डोमेन नेम ऑफ योर आइडिया, ठीक है. आप जो आइडिया वहां पर दिया हुआ है उस आइडिया में एक डोमेन नेम बुक करो. वो डैडी से कर सकते हो, किसी भी जगह पे कर सकते हो. आप लोग फैकल्टी लोग हो और किसी को जो वेबसाइट डेवलप कर सकते हैं उनको लेकर. टिल नाउ आई एम नॉट डेवलपिंग माय प्रोडक्ट, ओनली आइडिया, माइंड इट. मैं अभी आइडिया में बोल रहा हूँ, जो भी आइडिया है वो आइडिया में कर रहा हूँ. आप एक बोतल बनाएंगे, वो बोतल कुछ ऐसा है, और आप एक माउस बनाएंगे, वो माउस कुछ ऐसे. जो भी आइडिया है, जो भी सर्विस है, जो भी आपको कंसेप्ट है वो डालो. बुक ए डोमेन नेम ऑफ द आइडिया, जैसे कोई www.youtube.com, www.facebook.com, और आपका आइडिया है कि सपोज XYZ, so you just make it as a www.xyz. Okay, so like that way you just go through with that. Okay, next आपको वेबसाइट डेवलप करने के लिए बोल रहा हूँ, ठीक है. नेक्स्ट the leading page creations, one page website, long page express about the brand, business and startup. You just express about the brand. वो ब्रांड क्या है, वो क्या क्या प्रोडक्ट आप बना रहा है, क्या क्या है, वो सब वहां पर लिख दो. आपका जो भी है स्टार्टअप का, जो आप करना चाहते हो वो लिख दो, ठीक है. नेक्स्ट, अब एक अच्छी तरह से लोगो डिजाइन करो, क्रिएट अ लोगो. टिल नाउ यू हैव नॉट डिजाइन्ड योर प्रोडक्ट, you have not developed your product. Only what I am saying right now, only to develop the product, develop the website, develop your product, क्या करने जा रहा हो उसके बारे में लिखो, उसका लोगो करो. ये सब 5 स्टेप हमें आ गया. अभी आपको बोल रहा है कि एक लोगो डिजाइन करो. लोगो सबको पता है, ये देखो व्हाट्सएप का लोगो है, ये देखो एक लोगो है, ये कोको कोला का लोगो है. कोको कोला का लोगो कहाँ है, नहीं दिया है, ठीक है. तो ये देखो गूगल का लोगो है, ये देखो अमेज़न का लोगो. आप एक लोगो बना लो आपका स्टार्टअप का, ओके, उसको डालो वेबसाइट में. नेक्स्ट, डिजाइन योर आइडिया इन लीडिंग पेज, रिप्रेजेंट द प्रोडक्ट, व्हिच प्रॉब्लम यू आर सॉल्विंग, व्हाई योर प्रोडक्ट. आप एक वीडियो बना सकते हैं अच्छी तरह से, हाउ योर प्रोडक्ट सॉल्व द प्रॉब्लम, दैट यू आल्सो यू कैन रिप्रेजेंट. सो these are the things you have to develop, okay. And then थोड़ा मानी आपको खर्च कराऊंगा. Now the promote and landing the page in Google, Instagram and Facebook. Okay, वो ऐड आता है ना, वो Google Facebook में ऐड आता है, देखो Google में ऐड आता है. ज्यादा पैसा नहीं लगता है, 200-300 रुपया, 500-600 मैक्सिमम खर्च होगा आप 500 स्टार्टअप के लिए, ठीक है. तो आप ऑटोमेटिकली ये सबको वहां पे फेसबुक में प्रमोशन कर दो, इंस्टाग्राम में प्रमोशन करो, गूगल में प्रमोशन करो, ठीक है. टिल नाउ यू हैव नॉट डेवलप्ड योर प्रोडक्ट, राइट नाउ यू हैव नॉट डेवलप्ड योर प्रोडक्ट, ओके. यू आर ओनली रिप्रेजेंटिंग योर प्रोडक्ट इन फ्रंट ऑफ एवरीवन, करेक्ट, इन फ्रंट ऑफ नेटवर्क, in front of everybody, in front of world. You are representing your startup idea, you are representing your concept. Till now you have no product, no service, nothing, you have no business, it's totally artificial, okay, till now promote this landing page in Google, Instagram, Facebook. आप यहाँ पे कंप्यूटर साइंस पे जो पर्सन हो उसको पता है CTR, क्लिक थ्रू रेशियो, कॉस्ट पर क्लिक, ओपन लैंडिंग पेज, सबमिट योर ईमेल. आपका जो भी उसमें बहुत सारा लोग आपको जब भी वो प्रमोट करोगे ना फेसबुक में, यूट्यूब में, और गूगल में, व्हाटएवर, some of the persons are interested to in your product, और कोई इंटरेस्टेड नहीं होगा तो वो प्रोडक्ट में ना जाओ। आप तीनों प्रोडक्ट लेकर वहां पर कर रहे हो, तो तीनों प्रोडक्ट में कोई ना कोई एक प्रोडक्ट को आप लेकर, वो बहुत सारा सीटीसी आ जाएंगे, बहुत सारा लोग उनको जानने की कोशिश करेंगे। So you think that persons have curiosity to know about your product, persons have curiosity to understand about your product, persons have curiosity to purchase your product also, mind it. So did that product with value give you CTC value high, CPC value high, open landing page का ज्यादा होगा, वो वहां पे आप देख सकते हो। एंड ये करके, ये आप इफ आई एम गोइंग फॉर इन फ्रंट ऑफ यू ना, मैं एक लाइव एग्जांपल करके दिखा सकता हूँ, ये हो सकता है, ठीक है, आपका करके दूंगा और आप 15 डेज बाद मेरे को फीडबैक दोगे कि सर ऐसा हुआ है कि इस प्रोडक्ट में हमको बहुत अच्छा खासा फीडबैक मिला है। एंड ऑल्सो whoever you are giving you the interest, just send them, take their feedback, take their view about this. Okay, mind it, till now your product is not developed. Okay, now if you have 3 product or 4 product, by this 7 process you are becoming, you can understand about which product is your own, which your interest can be grown. If you think that if you stop in this 5th, 7th step, you feel that you are not interested in the entrepreneurship, you are not interested, you are not passionate about your product, you can stop it. Okay. Or if you think you are reaching the 7th step by a single product, that also you can done, and whatever the outcome you can getting, like that way you can get the benefit. But I want to say, you can try for 3 products only for that, and you can get the benefit for that. Okay, whatever the maximum output you getting, by that point you can grow in for startup. So this is our innovativeness measurement for launching the product, before the launching the product, process 1.0. Now I am coming to the process 2.0. 2.0 process is very simple and interesting. That I am giving you a chart. I am giving you a chart. Okay. I am showing there is a chat. Is anybody writing something? No. So, so measurement of innovativeness of any idea, the process number 2.0. How we can understand another process. So this process is basically, I'm giving you one chart. You just think about this chart, then you can very easily understand that how your product is perfect or not. That can understand by you. Okay. You show. This is our idea generation chart. Okay. You show this is a factor, that is market size, future growth, zero competition factors. 3 points. One is the market size, another is the market size, another is the future growth, and another is the zero competition factors. ये तीनों पॉइंट हाई और लो में हम लोग दिखेंगे. High or low means, suppose you have a startup idea, you have a product, and ये प्रोडक्ट का आप तीनों चीज देखोगे. 3 things you are identifying. One is the market size, another is the future growth, another is the zero competition factor. That means competition factor क्या है? Competition है मार्केट में और नहीं है competition. You have to think about it. ये तीनों फैक्ट्स में हाई एंड लो. नाउ व्हाट आई एम डूइंग, प्रोसेस नंबर 2.0. okay, idea generations process, that is innovativeness measurement process number 2.0. now there is a 3 point market size, future growth and zero competition. आप कोई भी प्रोडक्ट ले लो, कोई भी स्टार्टअप आइडिया ले लो, कोई भी आइडिया आप नहीं करने जा रहा हो, ले लो और उनको एनालिसिस करो. ये चार्ट है, ये तीनों हाई आएंगे तो आप वो स्टार्टअप में जाओ. ये तीनों हाई नहीं आएंगे तो आप वो स्टार्टअप में नहीं जाओ. तीनों हाई आने का मतलब क्या है? आई एम गिविंग यू वन एग्जांपल. सपोज e-commerce, Flipkart, Amazon, e-commerce business. I think you know about that. I am showing you e-commerce business. e-commerce के लिए ये मार्केट साइज आप बोलो कितना है, क्या है? e-commerce का मार्केट साइज ज्यादा है या छोटा है? बहुत बड़ा है मार्केट साइज. वेरी गुड. क्यों? क्योंकि e-commerce अभी सब लोग हम लोग जोमेटो से शुरू करके फ्लिपकार्ट से एंड कर सकता हूँ. ठीक है, जो भी कुछ और कुछ दिन बाद सब कुछ ही ये ई-कॉमर्स में आएंगे. ठीक है, द मार्केट साइज विच इज वेरी मच हाई. ओके, एंड अभी तक इंडिया में कितना परसेंटेज मोबाइल लिया है? स्मार्टफोन बहुत कम, टिल नाउ बहुत कम है. सबके पास स्मार्टफोन नहीं है. सबके पास स्मार्टफोन हो जाएगा ना तो ये आप एक दिन आएंगे कि देखोगे ये दुकान जो शॉप है ना वो बंद हो जाएगा. कम सेल होगा और सब ऑनलाइन में सेल होगा. ज्यादा से ज्यादा होम डिलीवरी होगा. ठीक है, तो ये सब आने वाला है, हम लोग देखेंगे. ठीक है, तो एंड वी आर द पर्सन, हम लोग सब एक एक करके देखते देखते जाएंगे. ठीक है, जैसे कोविड देखा है. ठीक है, तो ये फैक्टर है, दैट इज द मार्केट साइज, फ्यूचर ग्रोथ एंड जीरो. तो मैं जो बोलने जा रहा हूँ कि ई-कॉमर्स, सपोज सोच लो कि फ्लिपकार्ट का मार्केट साइज बहुत बड़ा है. अभी कोई आप ई-कॉमर्स बिजनेस करने जा रहा हो तो उसका भी मार्केट साइज ज्यादा है फ्लिपकार्ट की तरह. फ्यूचर ग्रोथ, फ्यूचर में यही चलेगा. ठीक है, फ्यूचर ग्रोथ यही इसके ऊपर ही है. ठीक है, फ्यूचर ग्रोथ भी बहुत अच्छा है. कंपटीशन फैक्टर, आप बोलो फ्लिपकार्ट के साथ आप कर पाओगे, अमेजन के साथ कर पाओगे? इज इट पॉसिबल टू कॉम्पीट विथ अमेजन? इज इट पॉसिबल टू कॉम्पीट विथ फ्लिपकार्ट? इज इट पॉसिबल टू कॉम्पीट विथ अदर XYZ, मेसो, हेनो तेनो, बहुत सारा है. कर पाओगे क्या? नहीं कर पाओगे. ठीक है, तो दिस इज वेरी वेरी इंपॉर्टेंट. आपका तीनों एक साथ यस नहीं हुआ, सो ई-कॉमर्स बिजनेस रिजेक्टेड. ओके, नेक्स्ट यू शो. मैट्रिमोनी.com पता है सबको. मैं मैट्रिमोनी.com के बारे में नहीं बोल रहा हूँ, अभी बोल रहा हूँ सेकेंड मैरिज मैट्रिमोनी साइट. सेकेंड मैरिज मैट्रिमोनी, इट्स नॉट मैट्रिमोनी साइट, इट्स सेकेंड मैरिज. आप सेकेंड मैरिज करने जा रहा हो तब ये चलेगा, सेकेंड मैरिज मैट्रिमोनी साइट. आप बताओ मार्केट साइज, मार्केट कितना है? कितना बड़ा मार्केट है? छोटा मार्केट है. सेकेंड मैरिज कम लोग का होता है, लेकिन पता नहीं है अभी ये टुवर्ड्स द हाई जा रहा है. सॉरी. ओके, नेक्स्ट इज द फ्यूचर ग्रोथ. फ्यूचर ग्रोथ ऑल्सो इज बिकमिंग हाई, बिकॉज आप जितना दिन आने वाला है उस टाइम भी ये होगा कुछ सेकेंड मैरिज, कुछ प्रॉब्लम कॉन्सेप्ट आ रहा है. ठीक है, जीरो कॉम्पिटिशन फैक्टर. कंपटीशन फैक्टर आप ये पहले बार सुन रहा हो. देखो सेकेंड मैरिज मैट्रिमोनी.com. ओके, सो कंपटीशन फैक्टर थोड़ा कम है यहाँ पे. तो दिस इज द जीरो कंपटीशन फैक्टर. जीरो कंपटीशन फैक्टर इज हाई. ओके, यस. सो नेक्स्ट, बट यहाँ पर भी देखो ये तीनों यस नहीं हुआ, सो वी कैन से दैट इट इज ऑल्सो. सो आप कोई भी स्टार्टअप आप करने जा रहा हो, कोई भी आप प्रोडक्ट डेवलप करने जा रहा हो, कोई भी आप कुछ भी, if you want to develop, if you want to present, if you want to produce, okay, if you want to launch the startup, you can set the things like that way and identify analysis. Now, the next step is that the amount of the market size, amount of the future growth, amount of the zero competition factor. Suppose if you give me 2 products or 3 products, I can measure you that the amount of the market size of this is this, amount of the market size of this product is this, amount of the market size of this product is this. तीनों का market size का हम दिखा सकते हैं. फ्यूचर ग्रोथ का भी तीनों का मैथमेटिक्स है, ये पूरा मैथमेटिक्स. मैं मैथमेटिक्स के साथ इनोवेशन और ये स्टार्टअप को जुड़ रहा हूं. ठीक है, कनेक्ट कर रहा हूं. आई एम कनेक्टिंग विद द मैथमेटिक्स. ओके, ऑनलाइन टीचिंग है. Going for another example, online teaching app. I know that in here 90%, 95% here who is the teacher. You show online teaching app, market size high. बहुत सारा लोग टीचिंग मार्केट में ऑनलाइन ले सकते हैं. फ्यूचर ग्रोथ आएंगे यार हाई. ठीक है, कंपटीशन फैक्टर कुछ कर नहीं पाओगे. जीरो कंपटीशन फैक्टर नो. ओके, हाई इज नो. बेसिकली दैट बहुत सारा कुछ है चल रहा है. ठीक है, ऑनलाइन टीचिंग. ये जब कोविड हुआ था उस टाइम में एक दिखा था कि स्टूडेंट्स एक्सप्रेशंस इंडिकेटर्स. ये अभी आप लोग मेरा मैं जो एफटीपी दे रहा हूँ, आप लोग सपोज सम ऑफ यू आर नॉट listening, some of you are doing your college, some of you are doing your own work. They are interested for the certificate only. And but जब कोविड आया था उस टाइम में एक प्रोडक्ट डेवलप किया था. दैट इज मैं स्टूडेंट एक्सप्रेशंस क्या है हमको वी कैन अंडरस्टैंड. आई कैन गेट द अंडरस्टैंड दैट आप क्या कर रहे हो. आर यू रियली कॉन्सेंट्रेट ऑन योर स्टडी और नॉट. ये कैसे कर सकते हैं? कैमरा ऑन करके कर सकते. लेकिन कैमरा ऑन करने से क्या प्रॉब्लम होगा? इफ आई ऑन ऑल द कैमरा देन देयर इज प्रॉब्लम इज मैं तो अभी पढ़ा रहा हूँ, मुझको दिखाई नहीं दे रहा है कैमरा में क्या हो रहा है. ठीक है, जब मैं सामने में पढ़ाऊंगा ऑफलाइन देन आई कैन अंडरस्टैंड कि सामने में क्या हो रहा है. ठीक है, लेकिन राइट नाउ आई कैन नॉट नो. आई एम जस्ट शोइंग द ओनली स्क्रीन इन हियर एंड नोबडी आप क्या कर रहे हो क्या नहीं कर रहे हो. आप रास्ते में जा रहा हो और कोई चाय की दुकान में चाय पी रहा हो, कुछ भी कुछ कर रहा हो, डोंट वरी, करते रहो. ठीक है, द थिंग्स इज दैट दिस पर्टिकुलर थिंग्स, दिस पर्टिकुलर फैक्टर्स, ये जो प्रोडक्ट है, ये प्रोडक्ट आपका जो कॉन्सेप्ट है, आप जो कर रहे हो, आपको कैमरा ऑनलाइन में ऑन करके रखना पड़ेगा. एंड देन आई कैन मेजर योर एक्सप्रेशंस. द सॉफ्टवेयर automatically measure your expression that you are concentrated on the study or not. Okay, that is the high, low, like that way. So student expressions indicator, that is a market size is low. कितना लोग ले पाएंगे? ये कॉस्टली डिवाइस है, कैमरा रहना पड़ेगा, उसमें सॉफ्टवेयर डिजाइन डेवलपमेंट करना पड़ेगा. ये फ्यूचर ग्रोथ इसका बहुत ज्यादा है. जीरो कंपटीशन फैक्टर ये कभी ये सोचा नहीं. ठीक है, so this is a new kinds of thing like that. कोरोना अफेक्टेड एड्रेस इंडिकेटर, ये सबको पता है, ये सब फ्यूचर ग्रोथ नहीं है. यहाँ पर देखो कोरोना अफेक्टेड जो है एड्रेस इंडिकेटर, किसका कोरोना है उसका एड्रेस निकालो. ठीक है, अभी देखो मार्केट साइज बहुत ज्यादा है, फ्यूचर ग्रोथ नहीं है. कोरोना होगा या नहीं होगा, कब आएंगे, उसके बाद हमारा स्टार्टअप काम करेंगे. जीरो कॉम्पिटिशन फैक्टर. ओके, सो दिस आर द प्रॉब्लम इज अराइज. The fact is that one very important thesis I am showing you, time is inversely proportional to the zero competition factor. जो भी स्टार्टअप, जो भी चीज सब जरूरत उस टाइम में मार्केट में लेकर. When the COVID was coming, at that time the marks is very much required. तो जो भी जो क्या बोलता है वो developing their mass, they can becoming high revenue generator. They are developing high generating the revenue high. वो उस टाइम में आपको सोचा होगा कि मैं भी बनाया था वो एक डिसइंफेक्टिंग करके वो कोई शादी की कोई कोई किसी मैरिज एनिवर्सरी मैरिज में मेरे 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 कोई भी अनुष्ठान बाड़ी में जाने के टाइम में उस अंदर जाने के लिए उस टाइम में होता था ना, उस तरह सा उस टाइम में आया था। लेकिन अभी क्या जरूरत है, अभी कोई भी यहाँ पर नहीं लगा था। कोई भी क्राउडेड जगह में जाओगे तो वो डिसइंफेक्टिंग जो टनल है वहां से जाना पड़ता है, वो तब डेवलप हुआ था। बट वो टाइम के हिसाब से अभी नहीं रहा। सो दैट इज रिक्वायर्ड आफ्टर दैट टाइम में आपको डेवलप करना पड़ता। अभी मैं 10 पॉइंट बोलने जा रहा हूँ। 10 पॉइंट, गिविंग यू 10 पॉइंट। ये 10 पॉइंट कोई भी स्टार्टअप फेल किस लिए होता है, ये देखो 100 स्टार्टअप में 0.5 स्टार्टअप सक्सेस होते हैं और 0.01 स्टार्टअप सक्सेस। ये 100 मैक्सिमम, आई एम सेइंग यू अप्रोक्सीमेटली। तो ये जो बाकी सारा स्टार्टअप वो फेल होता है, तो देयर इज सम एनालिसिस व्हिच आई हैव डन with the researchers have done. I am also thinking about that process, and I have getting this point 10 point why startup becoming fail. First point, missing innovations around human money making model. और मनी मेकिंग मॉडल क्या है? मनी मेकिंग मॉडल सपोज 2 दुकान है, ठीक है। एक दुकान में आप 2 दुकान में ही आप रसगुल्ला, कोलकाता में होता है रसगुल्ला, यहाँ पर बहुत सारा साउथ इंडियन और ऑल ओवर इंडिया का है, रसगुल्ला खरीदने जा रहा है। दोनों का साइज सेम है, ठीक है। लेकिन एक जगह में रसगुल्ला 12 रुपीज है और एक जगह में रसगुल्ला 10 रुपये है, लेकिन दोनों का क्वालिटी भी सेम है, साइज सेम है। आप कौन सा दुकान में जाओगे? 10 रुपीज वाला रसगुल्ला की दुकान में जाओगे। क्यों? यू कैन सेव योर मनी। सो मिसिंग इनोवेशंस अराउंड द ह्यूमन मनी मेकिंग मॉडल। ओके, मनी मेकिंग मॉडल कुछ देना पड़ेगा सब स्टार्टअप एंटरप्रेन्योर्स। ओके, सब जो भी कस्टमर है उसको। नेगेटिव कैश फ्लो हो जाता है किसी टाइम में। नेगेटिव कैश फ्लो का मतलब है वो इतना, अभी ये मनी मेकिंग करने के लिए क्या किया, वो इतना कम कर दिया उसका प्रोडक्ट का दाम, तो बहुत सारा लोग खरीदने लेके आए, लेकिन आफ्टर ए सर्टेन टाइम उसका कैपिटल भी प्रॉब्लम में फंस गया। दैट इज अ नेगेटिव कैश फ्लो। बिकॉज ये जो तीनों आइटम है ना, ये एक एक क्लास है, पूरा एनालिसिस करना पड़ेगा। लेकिन आई एम जस्ट एक्सप्लेनिंग यू वेरी शॉर्टली। एक्सपेंशन ऑफ द नेगेटिव मार्जिन। आप नेगेटिव मार्जिन कैसे? एयरसेल, दिस प्रॉब्लम इज अराइज फॉर द एयरसेल। ओके, एयरसेल में ये प्रॉब्लम हुआ। लैक ऑफ हाई स्किल कैपेबल पर्सन। हम लोग क्या करते हैं, स्टार्टअप करने के बाद मेरा मासी का जो लड़का है उनको ले लिया, उसका कुछ स्किल नहीं। मेरा काका का जो चाचा का जो भतीजा है उनको ले लिया। क्यों? क्योंकि ये हमारा फैमिली मेंबर है, लेकिन उसका कोई स्किल नहीं है, वो आके बैठ गया, कुछ काम भी नहीं कर पाया। तो वैसे कुछ मत करो, यू टेक द पर्सन हु हैव द स्किल प्रॉपर्ली। ओके, स्केलेबिलिटी विथ द रिकरिंग रेवेन्यू मॉडल, ये बहुत ही बड़ा प्रॉब्लम है, ठीक है। इफ यू आर डेवलपिंग वन स्टार्टअप, इन दिस स्टार्टअप each and every month to grow this startup, एक अमाउंट का जरूरत होता है। That amount is for the wages, salary, expenses of electricity, your own for your own expenses, आपका फैमिली के लिए एक्सपेंसेस भी है। ये सबको आपको वहां से लेना है। ईच एंड एवरी मंथ आपको एक रिकरिंग मॉडल बनाना है, वहां से आपका पैसा आते रहेंगे। एक मॉडल आते रहेंगे, उसके बाद आप साइनिंग करो, उसके बाद आप रख करो, वो अच्छा है, लेकिन आते रहेंगे, ठीक है। नेक्स्ट, मैं ज्यादा टाइम ले रहा हूँ, सॉरी। नेक्स्ट इज द मिक्स्ड मार्केटिंग सिग्नल, रॉन्ग पोजिशनिंग, scalability of the recurring revenue model, mixed marketing signal and wrong positioning. Wrong positioning, आप कोलकाता में जाओगे तो बड़ा बाजार जो जगह है ना, वहां पर सिर्फ आपको क्या बोलता है कपड़ा का दुकान मिलेगा। अच्छा, आप चले जाओगे पुस्ता मार्केट में आपको मसला का दुकान मिलेगा। आप चले जाओगे चांदनी चौक, आप वहां पे जाके इलेक्ट्रॉनिक्स का सब कुछ आइटम मिलेगा। आप चले जाओगे कॉलेज स्ट्रीट, वहां पे जाके आपको बुक्स मिलेगा। ठीक है, ये बहुत इंटरेस्टिंग चीज है। आप जहां पे जो चीज होता है वहां पे वो चीज करो। ठीक है, आपके कॉलेज के सामने देखो, जब ये कॉलेज नहीं एस्टेब्लिश हुआ था वहां पर कोई भी खाने का दुकान नहीं था। उस टाइम में वहां पर खाने का दुकान होता तो वो नहीं चलते। लेकिन आप वो कॉलेज में आप बहुत सारा स्टूडेंट है, उसका जरूरत है खाने का, इसलिए टिफिन का, इसलिए आपके कॉलेज के सामने खाने का दुकान आया। ठीक है, ये खाने का दुकान आप 3 किलोमीटर दूर में गांव में कुछ जगह में करोगे तो स्टूडेंट लोग नहीं जाएंगे आपके वहां। तो एक्चुअली द थिंग्स इज दैट यू हैव टू थिंक that mixed marketing signal and wrong position. Mixed marketing signal and wrong position. Okay, realize the product as a laggard. Okay, releasing the product as a laggard. अभी कुछ प्रोडक्ट का जरूरत है, आप काल करोगे, परसों करोगे, तरसों करोगे, नहीं हो पाएगा। ठीक है, ऐसा होता है। सेव योरसेल्फ फ्रॉम द गेटिंग ऑफ आउट कॉम्पिटेंट। सेव योरसेल्फ फ्रॉम गेटिंग आउट कॉम्पिटेंट। आउट कॉम्पिटेंट, आप मार्केट में अकेले नहीं हो यार, आपके साथ साथ और भी सारा लोग, उसके साथ नेटवर्किंग करो, नहीं तो आप पछताओगे। ठीक है, मिसिंग द प्रोसेस ऑफ द कन्वर्टिंग द फीडबैक इनटू द फीड फॉरवर्ड। हम लोग क्या करता है, प्रोडक्ट बनाता है, बेचते हैं, लेकिन फीडबैक नहीं लेता है यार। लेकिन सुनो, ये जो बहुत सारा ये आपको सबका ही होगा। सपोज कुछ टाइम में ज्यादा पैसा कट लिया आपका फोन के, आप क्या करते हो, वो कस्टमर केयर को फोन करके गाली देते। तो उसमें क्या होता है, ये आप सबसे अच्छा कस्टमर क्यों, आप क्यों अच्छा कस्टमर हो? If the startup thinking like that, if the mobile company think like that कि yes, ये हम इसको गाली दे रहा है, हमको ये ओवरकम करना पड़ेगा, वो फीड फॉरवर्ड करना पड़ेगा। लेकिन पूरा गाली देता है, देने दो, तब क्या होगा, आपका स्टार्टअप डिटोरिएट करेंगे। ठीक है, तो ये जो कस्टमर स्टार्टअप फीडबैक बहुत ही निगेटिव फीडबैक देते हैं, तो आपको पता चल जाएंगे कि ये प्रॉब्लम हो रहा है आपका प्रॉब्लम। मेरे कॉलेज में जो आपको निगेटिव फीडबैक देंगे ना, आपको पता चल जाएगा कि ये जगह को हमको ओवरकम करना है। आप वो स्टूडेंट को अच्छी तरह से देखो, क्योंकि वो आपको सही बोल रहा है। ठीक है, नेक्स्ट, बिजनेस मॉडल बिल्डिंग complete ecosystem. Ecosystem is a very important, my friend, that if you can कोई भी जगह में कुछ कर देते हो, वो नहीं सकते, उसको आपको देखना पड़ेगा आपका जो रॉ मटेरियल है वो नजदीक है या नहीं है। Like that you can develop your product. That is the very important. So these are the 10 points, and for that this is the ecosystem is very much necessary. And I know that all of your institutions have followed this, that awareness of the innovations of students, faculty, the project and innovative activity under the curriculum. Curriculum में अंडर ले लो ये innovation activity, startup activity, क्योंकि यही फ्यूचर है, और कुछ नहीं देने वाला, यही फ्यूचर है। नेक्स्ट आप देखो कि वर्कशॉप इन एडवांस टेक्नोलॉजी जो है उसके ऊपर जैसे इंडस्ट्री 4.0, 5.0, अभी 5.0 आ रहा है, उसके ऊपर एडवांस टेक्नोलॉजी, तो ये इंडस्ट्री विजिट, इंटर्नशिप, ये सब हो रहा है। ठीक है, देखो टेक फेस्ट इन JS College of Engineering, the tech is happening like that way. I know that GKCEM very nice tech fest is happening. Okay, that is a very much important. National level innovations competitions में जाना है, hackathon जाना है। ठीक है, लैब इंफ्रास्ट्रक्चर, फ्लेक्सिबिलिटी इन द टाइम, रात में काम करने दीजिए स्टूडेंट को आने दीजिए कॉलेज में। IPR filing and into the innovations ranking of the institute, startup incorporations under the institutions. Okay, so startup and engineering product के बारे में बताएंगे कि हम लोग क्या क्या ये सब ये इकोसिस्टम रहने से आपको ये प्रोडक्ट आप वेरी इजली, तो क्या क्या प्रोडक्ट हम लोग बनाए और इसी के हिसाब से आपको जो भी कॉन्सेप्ट आ जाएगा, यू कैन शो दैट दिस इज ए प्रोडक्ट व्हिच वी आर डेवलप, दैट इज ए essence effect, that is essence effect creations through internet technology 70, মানে that means if you can send a flower through internet from one side to another side, there is some device that can be evaporating that odor. Okay, you show this is the design approach of sophisticated computation. ये ऐसा चेयर है, इस चेयर में आप जैसे भी हो सके, जैसा उसका प्रॉब्लम है, सेरिब्रल पल्सी का प्रॉब्लम है, वो वैसे उसको चेंज करके करके हम लोग इसमें बैठा के उसको ले सकते हैं। उसका ये इनसाइड आउट यहाँ पे दिखा नहीं सकते, ये नीचे में इसका एक क्या बोलता है, इसका एक माउस, ओके, वो माउस भी लगा सकते हैं। ओके, नाउ दिस इज अ ब्रेल कंप्यूटर बोर्ड। ओके, दिस इज अ ब्रेल कंप्यूटर बोर्ड, जो आप ब्रेल वो कंप्यूटर तो देख नहीं सकते अंधे लोग, दैट इज द ब्लाइंड पीपल, हाउ दे कैन अंडरस्टैंड द कंप्यूटर, दैट इज आल्सो अनदर प्रोडक्ट यू कैन शो। ये मौसी क्या कर रहा है, ये ये बर्तन धो रहा है। ओके, ठीक है, तो ये हैंडी यूटेंसिल्स स्क्रबर, you can get all this product from my YouTube channel. You can write down in the YouTube Vishwarup Niyogi, you get everything. Okay, that kinds of product we have developed, that is handy utensils scrubber. इसमें देखो ये स्क्रबर यहाँ पर लगा दिया, ये एक मोटर है, मोटर जोर से घूम रहा है, यहाँ से ये विम बार निकल रहा है, ठीक है, यहाँ से पानी निकल रहा है, ठीक है। ये देखो, that is automatic drain cleaning system. Drain will be clean automatically drain will clean. ये देखो, ये हाथ में लाठी लेकर बुजुर्ग लोग जाते, उसको हम लोग ये इसमें कन्वर्ट किया था, उसके बाद अभी इसको थोड़ा चेंज करके ऐसा कर दिया, एंड ये बहुत सारा लोग मेरे से लिया, मुझसे ले लिया, बहुत सारा लोग। कुछ ये सिंपल चीज है, ये ग्रिल के दुकान से बना हुआ है, और यहाँ पर छोटा व्हील है, ठीक है। इसको आप मेरा वीडियो में देखोगे तो अच्छी तरह से पता चल जाएगा क्या है इसमें, ठीक है। तो ये व्हील वर्कर फॉर सेरिब्रल पल्सी एंड हैंडीकैप पीपल, ओके, और एल्डरली पीपल ऑल्सो जिसका पाँव में प्रॉब्लम है। ओके, दिस इज अ ब्रेली राइटिंग स्लेट। ये देखो, ये स्लेट है, ब्रेली स्लेट। ओके, अंधे लोग के लिए स्लेट, कैसे वो ब्रेली प्रैक्टिस करेंगे स्लेट में। ये डिजाइन एंड सिमुलेशन एस्पेक्ट टू द मॉडलिंग ऑफ ऑटोमेटिक कार्डियोवास्कुलर डिसऑर्डर। आपका कार्डियोवास्कुलर में कोई भी डिसऑर्डर आएंगे तो ईसीजी के लेकर यहाँ से हम लोग दिखा देंगे कि ये प्रॉब्लम है, ये प्रॉब्लम नहीं है। ये देखो, ये बहुत वेरी इजी एनीवेयर चेयर। अभी ये देखो, ये लोग ये फीस्ट में रान्ना कर रहा है, पिकनिक में, और यहाँ पर बैठ के उसको बैठने का जगह कर दिया। और इसी के तरह ये हम लोग यूज कर रहा है वो मिलिट्री के लिए। आपको पता है बीएसएफ कितना टाइम का खड़ा रहते है वो बॉर्डर में, उसको हम यूज कर सकते हैं, वो लोग यूज कर सकते हैं। ओके, नाउ सो स्मार्ट लुकिंग बैक लुकिंग हेलमेट। हम लोग गाड़ी में ही बैक लुकिंग ग्लास लगाते हैं, लेकिन ये हेलमेट लगा हुआ है। ये सेल्फ होल्डर रिलैक्सिंग पिलो, इसमें पिलो में क्या करते हैं हम लोग, कैसे मोबाइल करते हैं सोकर, वो कभी वो क्या होता है, वो मोबाइल गिर जाता है मुंह में, उसको हम ओवरकम कर दिया, ठीक है। ये देखो, ये आपका लीप आपके पास नजदीक भी होगा, ये आपका लीप कंट्रोल करता है आपका क्या बोलता है वो डायबिटीज, दैट इज ऑल्सो कंट्रोलिंग। ओके, it is automatic car for lower amputee person, it is eco handy van. Okay, ये देखो rise extensions module, ये देखो effort, this is the piezoelectric tire. Okay, this is a very interesting app based hardware based app one thing है, that is both way communications device for deaf mute real time process के deaf and mute तो मोबाइल नहीं यूज कर सकते, वो कैसे मोबाइल यूज करेंगे, उसी का एक एप्लीकेशन से। ये देखो कोरोना प्रोटेक्टिव ग्लास, कोरोना जब हुआ करता था तो ग्लास में क्या कर दिया, एक चैनल कर दिया, एक कंटेनर ले लिया, कंटेनर में अल्कोहल रहता था, वो अल्कोहल सारा हाथ में 10 मिनट्स अंतर चला जाता, ठीक है, ग्लास में चले जाता। तो ये बहुत ही पॉपुलर हुआ मेरा ये प्रोडक्ट। गवर्नमेंट इसमें फंड भी दिया है, इससे पहले भी बहुत सारा प्रोडक्ट उसमें फंड दिया है। Now I am not taking too much time on it. Basically, I am taking just 1 hour specifically. But यही चीज बोलने के लिए हूँ कि that is you have to think that आपको we have to think properly for our startup, because we are right now in the age of industry 4.5 to 5.0. So we have to think something. Now I'm showing you that at the 2000 how we are generating as your FTP is in this domain, that how we are, that is emerging field. So क्या आने वाला है इंडस्ट्री 5.0 में? I think you know about that industry 1.0, industry 2.0, 4.0 is right now in the 4.0 to the 4.5. Industry 5.0 और 6.0 2100 में क्या होने वाला है, वही हम आप लोगों को थोड़ा दिखाने वाला हूँ, just showing it. Just have a look.
Okay, here we can see you coming down the ladder now. I'm at the foot of the lift. That's one small step for man, one giant leap for mankind.
Thank you very much, everybody who is attending this session. I hope you are enjoying my short session.
Thank you so much, sir, for your wonderful session. I hope everyone enjoyed it. And you have been the last speaker of the 5-day FDP program, and we know that all's well that ends well. So I would like to request our Assistant Professor of Mathematics, Mr. Subhashish Saha sir, to share the appreciation certificate that we have prepared for you. Subhashish sir. And this is for all the participants. Thank you for joining. And all the links are given as usual, both in the live session and in the WhatsApp group. Sir, one of the participants have requested to share PPT.
I will share.
Okay, it is to
I
the
will
group
give
chat.
you. I will give you.
Okay. So please accept this from our end.
Thank you. Thank you. Thank you very much.
Thank you so much for your wonderful session. I hope the participants have enjoyed it.
If there is any question from the participants,
If anyone, if any of the participants have any queries for our speaker, please do ask. You can write it in the chat box. Does anyone have any queries? Okay, I don't think.
okay. So please send me some pictures of this particular webinar and that kinds of things. So I hope organizers please send me the pictures of this particular webinars, and I will definitely send you the PPT also. Okay. Thank you.
Okay,
Thank you.
sir. Okay.
So I'm leaving now.
Yes, sir.
Thank you, sir.
Now I request Onubroto sir, Dr. Onubroto Mondal, to give a vote of thanks to conclude the FTP, 5-day FTP.
I am audible, ma'am?
Yes, sir. Yes, sir, you're audible.
Okay. Good afternoon, dear all. Today I feel incredibly honored and privileged to have been allowed to extend a vote of thanks on this auspicious session. This is a momentous day in our college history as we have hosted this 1-week faculty development program on innovation in emerging field. On behalf of our college, I would like to propose a vote of thanks to our 80 participants and all delegates across all the streams of education from research to science and technology. Therefore, I want to extend my warm regards and heartiest congratulations to our keynote speaker, Professor Ramesh Chandra Panda, Chief Scientist, Wegrow. I also want to thank all the respected speakers, Dr. Meenakshi Anurag Thaler, Dr. Alka Agniyatri, Professor Dr. S. Kaliappan, Dr. Shunipa Roy, Professor Dr. Saurabh Saha, Dr. T. Motilal, Professor Dr. Sandeep Ghosh, Professor Dr. Bishwarup Nyogi, for taking their valuable time out and ensuring their presence here. As a college, along with other colleges and the universities that participated, we feel enlightened and believe that we got to learn many things from faculty development program. Words would fall short of describing how much knowledge we could derive from this FDP. A special thanks to our principal ma'am, Professor Dr. Mohadash, of Greater Kolkata College of Engineering and Management for providing immense support to make the faculty development program successful. Last but not least, I want to extend a vote of thanks to our organizing team, admin staff, and respected faculty members for making this event happen so beautifully. I hope we continue to work like this and organize such events in the future for the betterment and upliftment of our colleges. Best and regards, thank you. Thanks to all.
Thank you so much, sir.
Thank you,
And
sir.
there is just an announcement. All participants gets your certificate within 7 working days. Over to you, Shubhanurekha ma'am.
Okay, sir. Okay, now that the vote of thanks is delivered, I think we can end the meeting here. Thank you everyone for joining.
Thank you, ma'am. Thank you, sir.